So hello everyone, welcome back to the Scalar Academy YouTube channel. Myself Vamsi. In this tutorial, we will be learning about a client server architecture, which is a very important to understand system designing concepts. Okay, so we generally use a client server architecture in our day-to-day life. So like everything nowadays are client server architecture in model only, but we often don't know what is that client server architecture. So let's take some time and to understand what is client server architecture and how that has been processed and how that works and what are all the things that involves in client server architecture. Okay, so without wasting any time, let's get started. So before starting, so if you are visiting channel for the first time, don't forget to subscribe. If you like the content, please hit that like button up. If you have any queries or questions, please let us know in the comment section. Now let's start discussing about a client server architecture. So before jumping into the discussing about architecture, first we'll see what are the terminologies. Okay, so what is meant by client? So client might be user. Okay, so simply I will tell you with one example for better understanding. So one server might be some database or some backend thing. Okay, so you can consider client as working at front end. So let's say okay, let's take an example of CodeChef. Okay, so I have an CodeChef website. Okay, so I have logged in into using my credentials, and there will be something for search with username. Okay, so I want to know what are the ratings of my friend. Okay, so I will provide his particular username, right? Now, so what I will get all the details of his ratings and what are the contest histories and all. So what exactly happens behind this thing? Okay, so whenever you hit that submit button or search button, so it will go to a server. Okay, you can typically call it as a backend. So let's assume there are some db over there. Okay, which is storing all the informations of CodeChef users. Okay, so whenever you search for with that particular username, it will return you the details of the that particular user. Okay, so here this particular like the web application which you are uh, using to send and request is called as a client side which you are using directly, and this particular part you are using indirectly. You don't know, like someone who is an 12th standard or 10th standard guy came and is searching something on Google. Okay, he don't know exactly what is happening behind that. He knows something like if I enter like something, I will get something, that's it. Okay, so this is the back end side, so back end logic kind of stuff. Okay, so this is in simple what is client and server. Okay, we'll come to more details later. Okay, first we'll discuss what is a before client server architecture. Before client server architecture, so before this we used to have mainframe computers. We can call them as standalone systems. What does it mean? So let's say you have a one computer, you have one computer and you have created some database by using any SQL SQL database. Okay, on your local machine. Okay, so this is your system. Okay, so there is some SQL database you have created with some tables and all, and also you have created one a web page to access the SQL data. Okay, database. So can I ask few questions here? Now it is in your system, so can your friend able to access that data which is residing on the database from his own system without having any connection? No, it is not possible, right? So that kind of systems are called as an standalone systems, where the data has been restricted to one particular system. So you might be the client and you are the owner. Okay, server is residing in your machine itself. Okay, so others are not allowed to use that particular server. Okay, so that is the before client server architecture came into exist. Now let's see what is a client server architecture. It is not new. Okay, hope we have discussed this in while telling the terminologies of client and server. So let's see in detail. Okay, so basically let's say you're at a client side and you will make some a request. Okay, you will make some a request to the a server. What is a request? So a request can be anything. Let's say www.google.com can be one request, right? As I said earlier, searching with like entering a coach of username and expecting some all the details of that particular user. So here the request is, so search with this particular username, I want all the details. So that is one request, right? So this is a request. So what is this server side content? So it contains some DB, like databases. So tell me, is that always an data? Is that always an data? No, I don't think so. What might be? So it might be some calculations, logicals. Let's say you are using an EMI calculator applications. EMI calculator applications where you will be saying like I wanted to buy a home. Okay, so this is the amount I wanted, like 12 lakhs, I want 12 lakhs. And what will be the pay? Okay, what how much I need to pay? So per month, if the interest rate is 5% on the, and I'm willing to pay only, I would like to take the loan for 7 years. So is there any, do you think is there any DB involved here? No, but still it's a request, right? So I can say that there is a logic as well. So in server side I can say that both a DB and logic has been residing in particular machine. So here, after like whatever, if you have searched with user coach of username, it will go to database and it has to return something to the client, right? So it has to return the details of that particular user, right? So it will send some responses back to the client. Okay, so even if it is an logic side, like for this particular example, still it has to send some responses, right? So you have to pay monthly 23,000 kind of stuff. So even that is also a one response. So this is how the actual client server look architecture looks like, and we oftenly call this as an two-tier architecture. Two-tier architecture. So why two tier? So is there anything apart from a client side and server side? No, there is no other things involved. Okay. Now let's see few things which were involved other things as well. Okay. Let's say, so I have a client side and I have a, like I'm dividing the server side into the two parts. Okay. Logical and DB. I know that sometimes I need not to go to DB. Okay, so I'm pretty much sure that I don't have a work with a DB always. So what I will do, so I will go to simply to logic and I will check whether it's a logical based or it requires DB. So if it is a logical based, what I will do, I will solve the problem here itself. Okay, if it is an a logic based DB involved, I would go here. Okay, so this kind of things being called as a three-tier architecture. So one, two, three tier. So there is something like a entire architecture as well. Entire architecture. What does it mean? So let's say you have a client and you are using some load balancers to process your request to different servers. Okay, so let's say you might have one server, but there might exist of different clients. Okay, so n number of clients, no guarantee, right? Always. So do you think only one person can at a time can search in and Google? No. Okay, so many people, some billions of people used to search at a time. So how they are processing your requests? So if they have multiple servers, they will use load balancers to divide your request to and process your request to multiple servers at a time, to feel that you are in an, like you are the alone, you are using that particular system. Okay. So and so instead of going to directly to the server, let's say you have a cache, you have a cache memory. What I will do for the first time, I will request. Okay, so it will process to the server, like it will go to the first, go to the cache memory, and it will search whether whatever I have requested is there in cache memory or not. Okay, so if it is presented, if it is there in cache memory, it will simply return from cache memory itself. Okay, it won't go to the server, just because of the fact that I have found. Okay, I have response for your request. So if it is not there in cache, what it will do, it will go to server and it will take that response. Instead of going directly to the client, it will go to the cache first. Okay, cache memory, and it will put a replica or copy of that response in a cache memory, then it will return to client. Okay, so here this like this, so we are, I have simply used a load balancers and cache here. So there might be other things will also exist while designing complex systems. Okay, so in that situations you can call it as entire architecture. Okay. Yeah, so yeah, let's move on. So the next part is thick clients. Clients have been divided into thick clients and thin clients. What are they? Who are they? Right, you might have that question. Let's say, so a thick client is or something. Okay, let's say, hope you have a know a client side rendering and a server side rendering. What does it mean? So basically, so do you think all the calculations you do will go to the server? No. Let's say I have simply developed an calculator app. Okay, so I will enter two values, 2 plus 3. Okay, do you think it will go to the server and it will do some logic and it will come back to a result? No. So I can handle this in my code base only, like at the client side as well. So that kind of systems will call as a thick clients. Okay, who does their work at the client side only. So some of the famous example, like, so we use a lot of things in our day-to-day life. So fewer Outlook and G Talk, Google Talk, and also some online trading portals as well. Like it involves a lot of calculations, right? So yeah, so that is about thick clients. Now we'll talk about thin clients. So it's quite opposite to the clients. Okay, so in thick clients we are rendering at the client side. So in thin clients we go to the server and will process our request in server and will get some response for a response. So that is a thin clients. We can consider anything like simply and a school database or college database. Okay, so where if you are searching for an employee or any student, so your request has to go to the server side and it has to get all the details. Even in very first example that we have discussed, CodeChef application, so even it has to go to the CodeChef database and it has to process that request, so it has to return that. That's it. Okay.
We generate around 80 zettabytes of data today, which is almost 40x increase in the last decade alone. The need for data scientists and machine learning engineers is skyrocketing. Experts estimate that this data will grow even more to 200 zettabytes by 2025. Have you ever wondered how this data is stored? Can this data fit into a single server? Most of the software engineers talks about partitioning the data to solve for the limitations that is posted by a single server. Hello and welcome to my new video on sharding. I'm Mohit Yadav, and in this video I'll try to explain you the basics of sharding, and also I'll give you some of the strategies that is associated with sharding. When it comes to managing large data sets, we really have three choices. The first choice is vertical scaling, or functional scaling, or horizontal scaling. The vertical scaling is increasing the capacity of server on which data is stored. If the capacity of the server was earlier, let's say 512 GB, as the storage needs increase, we might want to migrate it to a server that can hold up to 1 TB of data. As you might have already guessed, this is not a very scalable approach. Hence, let's look at the second approach, which is functional scaling. In functional scaling, we try to split the data logically. I'll give you an example. Let's say you are running an e-commerce website and initially there were not many users, so you were storing everything in a single data node. All the tables which are keeping information about the users, their purchase history, and inventory was also stored in a single database in a single node. Now, as users are increasing, as you're getting more users, their purchases will increase, the number of users will increase, the inventory will also increase if you are onboarding new sellers. So each of these tables will independently increase. One way to scale your application is to break it into smaller pieces. One application will manage the users, the other will manage purchases, the other will manage the inventory. You might also have different microservices managing each database and sharing the data to other services via API. This logical split is almost always implemented at the application layer, meaning that there will be a piece of code which will be responsible for routing the read and write request to the designated database or the designated microservices as well. This is what we call as functional scaling. Horizontal scaling is what is called as sharding. In simple words, sharding is a way to split and store a single logical database or dataset over multiple servers called data node. This is in contrast to functional scaling, where we were splitting the data logically. We are segregating users, orders, purchase history, inventory into different data sets or microservices. Here, I will be splitting a homogeneous set of data, homogeneous table. For example, I will be splitting a user table or a order table. This is what we call as the sharding, right? And because of this very reason, because it is a uniform way of splitting data, we split the data based on one column of a particular table. Because of this reason, it can be automated and it can be implemented at an application layer or at a database level as well. Now let's try and understand how database decides where one row will go or where it will not go, which data node a particular record needs to be stored. To understand that, let's see how a request propagates through the entire system. All the requests will start from what we call as a client. A client can be a mobile device, a web browser, or living room device as well, right? From the client, the request will go to the load balancer. I'm skipping the DNS resolution step. So it will go to the load balancer. Load balancer will then transfer this request to one of the many available application server, right? This is application server. This will again be an application server and an application server. The application server will then push this message. Let's say it's a write request. So it will try to write to a database. Currently, since we just have one data node, all the requests will go to this particular data node called data node 0. Now, as the volume increases, what we want to do, we want to split the data to two different data nodes, right? So let's add two more servers. So this is server 0, this becomes server 1, and this is server 2, right? Now, let's dig deeper into one table. Let's say we want to know about the order table. In order table, we are maintaining order ID, we are maintaining user ID, we are also maintaining the item ID. Let's say for simplicity, these are the only three columns, right? Now, for user ID 1 purchased item 1, user ID 1 purchased item 2, user ID 2 purchased item 1, user ID 3 also purchased item 2. Let's say these are the only 4 records. Now to split the data, what we need to do, earlier all the requests that were coming were going to one single data node that was available. But now, based on the value of any one of the column, we can decide algorithmically where every record is going to be stored. So let's try to insert each record, and the algorithm that we are following for simplicity's sake is the modulo algorithm, which is that I will take modulo of column value, whatever column we decide. Let's say I decide user ID, and I take a modulo with the number of available server. How many number of available servers are there? 3. So modulo 3 will come. And this column that we have selected as a sharding key is user ID. Shard key is basically the column on which I'm determining how distribution of the keys will happen, right? So I'll take the first example. I take user ID. The first row will basically go to shard 1. So I enter order ID 1 here. The order ID 2, user ID is 1. Again, modulo 3 if I take, it is 1. So it will come here. The third one, the order ID 3, 2 modulo 3 is 2. So order ID 3 will come here. For 4, 3 modulo 3 is 0. So order number 4 will come here. That is how the distribution in an algorithmic fashion takes place. This can also be done in a slightly different manner, wherein we don't do things like this. We don't have an algorithm to determine where each row is going. But what we do is we create a namespace. We create one more table. We create one extra server here. This is called as a namespace server. What this does is it creates a mapping of every primary key. So for example, order ID 1 is stored in server ID 0. Order ID 2 is stored in server 1, and something like that. And whenever you want to retrieve this value, you first query the namespace server, find out which server ID is storing that particular record, and then query on that particular node. So there is one extra step that comes in this kind of a fashion.
Hi, I'm Mohit Yadav and I teach at Scalar Academy. After taking more than 200 interviews, I've come to a realization that most people lack one common trait, which is to design a good relational database. Now, why this problem arises? The root cause of this problem can be attributed to that many people come from a NoSQL background, and hence they try to denormalize everything and put all the attributes in a single entity. Therefore, it becomes very critical to understand the basic fundamentals of schema design. This will not only help you in clearing the interviews, but it will also help you in building a repo and having technical discussion amongst your peer group. If you are someone who often finds it difficult to convert the real world requirements into the entity and relationship diagrams, then this video is for you. In this video, we are going to discuss about relational schema design using LinkedIn as an example. We are going to discuss about one-to-many relationship, many-to-many relationship. Apart from that, we'll also see when it makes sense to separate two entities even though the columns in both the entities are same. After this video, you'll be able to convert high-level requirements into relational database schema with ease. Now, to design any relational data store schema, all you need to do is list down all the features. Then where you need to identify all the entities and relationship that will support your feature list. To do that, underline all the nouns and verbs. All the nouns will then correspond to either entities or it will be an attribute in one of the entities that you have already listed. The verbs will translate into either the status changes or the relationship between two entities. Now let's see this trick in action and design schema for LinkedIn. So let's go ahead and see how to apply those tricks in action. The first feature is that user should be able to view and edit his profile, which contains the following information. This gives us a hint that there should be a user entity table. So let's add user entity. It can be a user profile as well. Let's keep it user profile for now. Every entity that you create will have one attribute, which is ID. This will basically be used to uniquely identify a user profile. The other attributes would be coming from the next set of requirements. On top left, a user should have profile photo. On the right side of profile pic, we should also show name and contact information. So let's add these attributes inside a user profile entity. So we'll have a profile pic. Profile pic can be stored in two places. One is in the database itself. If you store the profile pic in the database, the amount of storage that is required to store all the information of the users will be very large. So it's wise to store all the images and video links that are associated with a particular profile into a file store like S3, or we can also store them in a CDN, right? So instead of storing the profile pic, I'll store the URI, which will either correspond to S3 or CDN or maybe any other file store as well. The next information that I would have to store is the name and contact information in form of an email or phone number or both. A user can have multiple skills. So there are two options of adding the skills. The first option is add that as a list object in the same user profile table. So if I am adding this in the form of a list, how that will come up is sample values will be Java, JavaScript, and so on, right? This poses one major problem. The major problem is that if I want to find out all the users who have Java in their skills mentioned, so the problem would be that I would have to write something like a select star from user profile where skills like star Java star, which means that this is going to be a scan operation. So if I have multiple rows in my database, then I will end up scanning all the rows. If I have 1 billion rows, I will scan 1 billion rows. So this approach will not scale. The other downside of this particular approach is that I will not be able to auto suggest skills to the user, because that will be again a scan on all the rows that are present in the database. So what we'll do is we'll add one more entity called skills. Now this skill, there are two ways of adding skill, right? Either we can have the skill ID, name and user ID stored directly here. If I do something like this, then again autocomplete will be slow because there will be multiple users and multiple users will be having multiple skills. If you look closely, the two entities, the user profile entity and the skill entity, what is the kind of relationship between these two entities, right? So user can have multiple skills. Similarly, a skill can be having multiple users, right? So it's a many to many kind of a relationship. To model a many to many kind of a relationship, what you should do is you should create a mapping table called user skills. This will, again, all our entities have an ID, so it will start with an ID. We'll also have a user ID here and skill ID. And we can remove the user ID that was there in the skills object. If we read the next set of requirements, it states that we need to keep information about educational institutions and employers. And if you look closely, the attributes over here in the educational institutions and the employers are same. So what I can have is I can create an entity called organization. Inside an organization, I can have an ID field and all the other fields that are there, depicting name, start year, end year, and let's say description. And I will need to have one more type. This type will store information of institution or company. So from the looks of it, or for the given set of features, this table works really well. The challenge over here is that what if I want to add other attributes? Let's say I want to add CGPA in the educational institution and I want to add salary details inside employers. The problem here that comes is that I will have to add CGPA as a one column here and salary also as one more column. Now depending upon whether the type is institution or company, either CGPA will be null or salary will be null. Now, it is not a very good idea to enforce application logic in your database. Just by looking at the database, you should be able to figure out that what each column means. So, to avoid such kind of a problem and to have a design that is extensible, what we can do is we can split this into two tables. One would be a education and the other one would be a company. Both will have ID, both will have name, it will have start year and it will also have end year. Type is not required because we have already split the table. But this alone will not be able to give me any sense of which user went to this particular university, which users went to this particular company. Now, what is the relationship between user and education and user and company? We would realize that a user can go to multiple companies and he can also go to multiple institutions for completing his education. Similarly, an institution might have multiple students who are studying in it. In a company also there can be many employees. So it's again a many-to-many kind of a relationship, and we have learned in the example above that whenever we have multiple many-to-many kind of a relationship, we create mapping entities. So there will be one table for user education and one table for user company. The attributes will be ID, user ID and education ID. Education might not be a better word, or the better word can be institution over here. So we'll have ID, we'll have user ID and we'll have company ID as well. Now if I want to find out all the users who have went to a particular institution, what I'll do is I'll go to user education table and I'll query select start from user education where education ID equal to the institute ID. The next requirement is to have recommendations. Now a particular user can either give recommendations or receive recommendations. Since this is a list, it does not make sense to add this in the attributes of your particular user. It makes sense to have a separate entity. So let's go ahead and create a recommendation entity. We'll have an ID, the person who is given the recommendation, so let's say user ID for that, and it will also have a recipient ID, right? Do I need to create a mapping table in this case? Now a particular recommendation will have just one user ID and it will also have one recipient. That information is actually captured in this particular table, so we don't need a mapping table in case of a recommendation. So if I want to find out all the recommendations that I have, what I'll do is I'll go to recommendation table and I'll select star from recommendations where recipient ID equal to my user ID. So the next requirement is having connections and followers. How connection and follower work is that if A sends a request to B, that means that A will be able to see all the public posts that are made by B. If B accepts that particular connection request, then B will also see all the posts that are made by A. Let's have a design that can model this particular feature set. So we'll have a connection table. Inside this connection table, I'll have an ID, I'll have user 1, user ID 1, and I'll have user ID 2. Whenever a new connection comes in, I'll add that particular row here, and as soon as B accepts the request of A, I'll add one more row. So if I want to find out anybody's followers, all I need to do is select star from connection table where user ID 2 is equal to the given user. So for example, A sent a request to B, so A is a follower of B. So if I want to find out B's follower, I'll need to query the second column, user ID 2. And as soon as it's a bidirectional mapping, I'm adding that particular row as well. So I'll be able to find that out as well. The problem, however, is that I'm taking 2 times the space that I should be taking. So to optimize on space, what I can do is have one boolean column called is accepted. Now if A and B are a connection, not a follower, that means that A sent a request to B and B accepted that particular request, I can keep the accepted flag as true, otherwise it will be false. Now if I want to find out all the followers of A, if accepted flag is true, then I'll query based on either user ID 1 should be equal to A or user ID 2 should be equal to A. If it is false, then only user ID 2 should be equal to A. The last set of entities that I'm going to talk about is post, comment and like. Let's go ahead and create entities for all of them. So there will be a post entity. Inside this post entity, we'll have an ID. Now, what is the relationship of a post with a user? One user can have multiple posts, whereas the reverse is not true. One post will be written by just one user. So let's add user ID in the post entity table. Whenever you have one to many kind of a relationship or many to one kind of a relationship, add that attribute of the first entity in the dependent entity. So the first entity over here was user, so we'll have user ID inside post ID, which is the dependent one, and some text to go along with it. Similarly, in comment entity also, we'll have an ID. Comment is made by a user, so comment is dependent on user ID. Comment is also dependent on post, because a comment cannot exist independently of a post. So we'll also have a post ID here. Again, this is an example of a many to one kind of a relationship, and it will also have text. Now for likes, we can have two tables. One is a post like table. Inside post like, we'll have ID, post ID, again one to many kind of a relationship, and a user ID. On a comment like table, we'll have the same attributes, ID, comment ID, and user ID. If you notice here, the post ID and comment ID are basically the entity IDs that this like is made on. So for example, in post like, the entity was post. In comment like, the entity was comment. We can club these two tables together, similar to we saw in educational and company. Combined table will look something like a like. Like will have an ID, it will have entity ID and entity type. Now this entity type can be of two types presently, either post or comment. Finally, we'll also have the user who has liked this particular thing. If I want to add one more entity, let's say a user can have vlogs as well. So what I'll do is I'll create a vlog table over here, and in this type, I'll add type equal to vlog as well. So without even adding one more table, my like table will work. I hope this video gave you some sense of how to design schema for big systems like LinkedIn. This is just a glimpse of what we teach and how we teach at Scalar. Lastly, we'll keep on adding videos on similar topics. Therefore, please subscribe to our channel to get notifications about new videos. Hi, I'm Mohit Yadav and I teach at Scalar. In this video, we are going to talk about Delicious, which was a site that started off as a college project and then scaled to 5 million users. In this video, we are going to learn about vertical scaling, horizontal scaling, and the challenges that comes with it. Now coming to the topic, Delicious. Delicious was a website that offered users to save bookmarks so that they can access it from any computer. The website was started in 2003 by a college student and was later acquired by Yahoo in 2005. This was way back when Chrome was not there and there was no bookmarking service either. By the end of 2008, the website had more than 5 million users and approx 180 million bookmarks saved. This scaled from one laptop to 5 million users. We'll start from the day it went live on the creator's laptop. Let's start by understanding what happens when you type Delicious in the browser. Now, browsers do not understand the names. They only understand IP addresses. Hence, we need a way to convert this URL into an IP address. In case of Delicious, DNS will return the IP address of the computer on which it is hosted. Now, since every machine which is connected to internet gets an IP address, and every time we connect to internet, this IP address may change. Therefore, we need to associate a static IP which does not change when you connect to internet again and again. And we need to assign this IP to the computer. To get the whole system up and running, we first need to purchase a domain name called Delicious and then map it to the static IP of this computer. If you look closely, there are two major kinds of requests involved. One is the get or the read request in form of get user bookmarks, and the second one is post or write request in form of add bookmarks. Using the IP address that is returned from the DNS, both this request will go to the same computer. And within the computer, there will be two things running. One is the application server, which will listen to all the requests that are coming to the HTTP port 80. And the second one will be the MySQL server, which will store all the bookmarks that my users are trying to save. So till now, my life is good. I'm running the website for free and I'm using campus internet. My database is set up on my personal computer, so I'm not paying anything for the resources. And I'm making money out of ads. Soon, the website became an instant hit. The user base kept on growing and the challenges also kept on piling up in the same proportion. Every time a new bookmark was created meant that there is a need for extra storage to store this particular bookmark. Now the best available hardware at the time was around 50 GB of hard disk, 128 MB of RAM. This was basically a Pentium 4 era. To keep up with the demand, he bought better hardware, meaning he bought a better laptop, a better computer. The bottom line is he bought more RAM or more hard disk or maybe multiple cores. But soon, even the best hardware available was not enough to keep up with the growing demand of the business. In fact, most companies of the era focused on upgrading their hardware to solve the growing needs of the business. This form of scaling is basically called as vertical scaling. However, Delicious founder was different. He knew in the longer run his approach will not work. Not only he will be restrained by his system resources, but he might also lose valuable customer data if his laptop crashes. This website is not reachable when his computer is turned off. Hence, this computer was a single point of failure. To overcome the challenges of vertical scaling, his friends suggested him to utilize their own laptops or computers. The idea was to uniformly distribute the incoming requests to available computers. This mode, where we are overcoming the scalability hurdles using multiple servers and computers, is basically called as horizontal scaling. Now, we know that the client talks to the DNS to get IP address corresponding to a particular website. But the question is, the website is now running on multiple server instances. We have, let's say, 4 servers running the Delicious website. Which of the 4 servers available should be stored in the DNS? If I randomly choose any of the available server, all the requests will go to that particular server and that server will eventually die. To fix this, have one machine whose responsibility is to route the traffic to the available instances. This machine will lie between the DNS wall and the servers that I have. And the DNS configuration in the registry, I'll mention the IP address of this special machine and not of any of the instances that I have. Now the question comes, won't this special machine also die if all the requests pass through it? The reason why this special machine will be able to handle higher traffic is because it is only routing the traffic that it is getting to one of the available instances. It is not doing any compute or memory intensive task. And modern day machines can handle up to 1 million requests per second. So using this, we have solved for high number of queries per second on my system. But there is one more problem that still exists. That is single point of failure. Just like any other computer, what if my special server also dies? To solve this, we can have a standby routing server which will not serve or route any request. When my main server goes down, swap the main server with the standby server. But how do I swap? Should I change the IP address in the DNS registry? Doing this will take minutes. Can we do better? Yes, we can. Remember, we assigned a static IP to the special server. The key here is take the static IP and assign it to the passive one. Passive one meaning the standby server. The special server we just spoke about is called load balancer, and we will study more about it in the upcoming videos. Hello, hi and welcome everyone to my new video on system design. I am Mohit Yadav and I teach at Scalar. I've been fortunate enough to work on systems that saw over 10 million concurrent users, and I've also built data pipelines that can crunch around 1 TB of data per day. Having led teams at Nutanix and Hotstar which have built such massively scalable systems, I'm here today to share the same knowledge with you all. In this video, we are going to learn about a very important system design concept called load balancing. To understand how a load balancer works, we first need to look at how a typical request flows through my entire system. A request will start from a client application. This client can be a browser, a web app, or maybe a mobile app. This client will call DNS to resolve the domain name that I'm trying to access. For example, if I type delicious.com in the browser, the request will go to the DNS server. DNS server will give the IP address corresponding to delicious.com and it will return it back to the client. Subsequent request will then go to the IP address that is returned by the DNS. This IP address can either correspond to the application server which is capable of catering to that particular request, or it might correspond to a proxy server which will act as a gateway to route requests to the application servers. Since this DNS happens to be the first point of contact for almost every request on internet, this system needs to be very scalable and available. The amount of load that this system takes is immensely huge as compared to any other system in the world. Also, the latency, which is nothing but a measure of time it takes for a system to respond to a particular request, needs to be extremely low. What would be the total latency over here? If I have to calculate the total latency of the system, it would be DNS resolution plus the request time. So request time will be application dependent, but the time it takes for DNS resolution is same for every request on the internet. If this time is high, the overall latency of the system increases. So my goal as an engineer should be latency of the DNS resolution should be extremely low. And to achieve this, we try to cache the DNS mapping at various stages. What are the various stages? We try to cache it at the browser, we try to cache it at the OS, ISPs, and then we also replicate it to DNS servers. There's one more important thing. Now assume that if the DNS servers are placed at only one geographical location, let's say US, and the requests are originating from, let's say, India, it will add lot of latency because India and US are geographically apart from each other. And that's the reason this geographical distance will add to extra latency. Typically, it takes around 200 milliseconds to for a request to reach from US to India. So every request which is originating from India and is getting resolved in US will have an inherent lag of 200 milliseconds. It is not a very desirable outcome, right? So to avoid that kind of scenarios, DNS is basically replicated across the globe, and because it is replicated across the globe, updating or changing the IP address on these DNS server is not a very easy task. This change will have to be propagated to the entire world, which might take hours or even days in some cases. I have a wonderful resource in the description that you should refer to understand how a typical DNS works. Also, I would like to pause here and request you guys to please like and share this video and support our free content on system design topics and software engineering in general. Now, coming back to the topic, in the example that we considered, the DNS was just returning one IP address. It will work for most of the websites in the world, but consider this DNS resolution to be of Google or Facebook scale, basically a tech giant which have massive amount of queries, massive amount of user base, and they process billions of queries per second. In those cases, if I just return one single IP address, chances are that all the requests of the client will hit that particular instance, and there is no such instance which would be able to handle traffic of the entire world. So that machine will eventually die. To avoid this, what typically these tech giants do is they deploy multiple IPs on which the client request will resolve to, right? So instead of returning, let's say IP1, they return a list of IP. So IP1, IP2, IP3, IP4, and they send this particular list to the client. Now it is the responsibility of the client to figure out which IP to talk to. Typically, in DNS resolution phase, it tries to follow up something called as a waterfall model. What is a waterfall model? It will try to connect with the first IP. If the connection is successful, it will not connect with IP2, IP3 or IP4. If the first connection itself is successful, it will connect with the first IP. Now, if all the clients will start connecting to the first available IP, that also is not solving the problem. Even though I'm returning a list, but essentially each client is connecting to the first IP that is returned. So if I return the same IP list to every client, I will be gated by a limitation that every client will try to connect to the same IP. What DNS do is, instead of returning the list like this, they return the list in a shuffled order, meaning that it is very much possible that user 1 gets a list like IP1, IP2, IP3 and so on. User 2 gets a slightly different order like IP2, IP1 and IP3. User 3 gets a list like IP3, IP2 and so on. This way, I have successfully distributed the load to my available instances, right? Another way to do traffic routing is to use a geo-based routing strategy. That means people who are residing in India will get a IP address corresponding to India data center. People who are residing in US will get a IP address corresponding to US data center. That also bridges the latency gap. Why? Because if user sitting in India gets a IP address of the data center in US, there will be an inherent lag in resolving the subsequent request. So it makes sense to have a geo-based routing strategy as well. Now we have identified the IP address which will be responsible for answering all my client requests. This could either correspond to a single server or a gateway server which will route traffic to my available servers. If we choose to route the entire traffic to a single computational server, the only way to scale is to run our application on a better hardware. However, if we choose to route traffic via gateway server, we can add more instances as and when required, and adding more instances will help us cater to multiple or higher number of incoming requests. Another important advantage of this approach is that this allows application servers to keep evolving without the need to make DNS changes. Now this DNS changes, we have learned that it might take hours or even days in some cases. So if we have to update the code of my application server, all I need to do is add more application server, let's say AS1, AS2 and AS3, register these application server in the load balancer and deregister the older ones, and I have saved myself from updating the DNS record. If this was the one server case, the IP address of that one server would have changed and I would have to update the DNS mapping as well. Lastly, one very important benefit that we are getting out of having a gateway machine fronting my application server is that this gateway machine also provides a layer of security. How? All the machines that are below the load balancer can typically be in my private network, meaning these instances can typically be disconnected from internet, and whenever they want to be using any data from the internet, it will come only via load balancer. So my load balancer is the wall that connects to the internet, and my application servers just talks to the load balancer. The load balancer also takes care of encrypting and decrypting the message and securing the request via HTTPS. So my load balancer layer can typically be HTTPS, and my application server can implement a HTTP protocol. Now there are two major types of load balancer. One is a hardware load balancer and the second one is a software load balancer. A hardware load balancer is a specialized hardware which takes care of routing the requests that are coming to it. Most likely you end up using a software load balancer which can run on a commodity hardware to route traffic. And this software load balancer is again divided into two types. One is a layer 4 load balancer and the second one is a layer 7 load balancer. This layer 4 and layer 7 translates to the OSI network layer, right? Layer 4, if you remember, is the transport layer, and layer 7 is basically the application layer. In the transport layer, the only thing that we get from the incoming request is the IP information. So we only get the source IP, and based on the source IP and the port in the incoming request, we route the traffic to the available servers. Whereas in the application load balancer, we get much more richer information in form of the headers that are passed in the request, the query params, the path params, and also the HTTP method. But what are the pros and cons of using both, right? In what cases should you use layer 4? If you look closely, in the transport, we only have to rely on source IP and port, and based on this, we route the traffic. So the amount of computation that we are doing in the layer 4 load balancer is less as compared to the computation that we are doing in application where we are processing the entire request. So in layer 4, it will be much faster to route the request, whereas in layer 7 it will wait for all network packets to arrive before deciding which server should be able to serve my incoming request. But these days we are having much better hardware which are drastically reducing the slowness factor of layer 7. However, there is one more distinction why you should still use layer 4 in some cases, because in layer 4 we are exposing only minimal information to the load balancer. We are only exposing the source IP address and nothing else. Hence, layer 4 load balancers are slightly more secure as compared to layer 7, where we could extract the entire information about an incoming request. The last thing that we want to look at is how do we even route traffic from a load balancer to my available application server. Load balancers keep a registry of all the available application server. So it will keep AS1, AS2 and AS3, and it will also maintain the state in which these systems are. So for example, AS1, 2 and 3 are in available state, so it will mark it with green. And if there are other servers which are not in available state, it will mark it with red, and request will not be routed to those servers. But what should be the routing strategy? Our goal is to try and optimize on the resources that we have, and based on the resources, we should route the request. One of the very trivial or the brute force way to route traffic is to send the first request to first server, second to second, and the third request goes to the third server. The fourth request again goes to the first server, fifth request goes to the second server, and sixth request goes to the third server. And we'll keep on doing this circular distribution of requests to all the available servers in my system. This kind of routing strategy is called as a round robin strategy. But as you can see, this is not a best strategy to go for. Why this is not a best strategy? We can see that the application server 2 has twice the RAM, twice the number of cores, and twice the number of disk available as compared to application server 1 and 2. Therefore, it should ideally process more number of requests as compared to the other servers. So what we can typically do is make the routing strategy in such a way that application server 2 gets approximately twice the number of requests as compared to my other available servers. How I can do that? I'll route first request to the first application server. Second request will go to my second application server. Third request will also go to the same server. Fourth goes to application server 3. Fifth goes to 1. 6 and 7 goes to application server 2, and 8 goes to application server 3. That ways, first server gets 2 requests, this gets 4, and the last server will get again 2 requests. Application server 2 is getting 50% load. Application server 1 is getting 25% load. And similarly, application server 3 is also getting 25% of the load. This kind of routing strategy is called weighted round robin. The other routing strategies worth mentioning over here is a least connection routing strategy. This least connection looks at the number of active connections that are there with the application server, and server with least number of active connection will get the next new incoming request. For example, if there are 5 connections to application server 1, 6 connections to application server 2, and let's say 4 connections to application server 3, the next incoming request will go to application server 3, and this number will increase to 5. As soon as this request is processed, the number will again decrement to 4. Here also, we have the same problem as in round robin strategy, that we are not accounting for the capacity of the instance. To accommodate that, here also we have a weighted least connection routing strategy, where you can assign weights to a particular application server and routing will be done based on that. The last strategy that I'm going to talk about is basically a least response time strategy. In least response time strategy, we look at 2 parameters. One is the number of connection it has, and the second is the average time it takes to complete a particular request. Considering these 2 parameters, we decide which server should cater to my next incoming request. Now, all these strategies that we have covered till now work well if every app server is equally well equipped to answer my query. meaning that if I have a query A, I will get the same response if I send the query A to application server 1, to application server 2 or application server 3. Regardless of where this query is getting processed, I will get the same response. This kind of a system is basically called as a stateless system. The last set of routing strategy that I have not covered in this video is called a hash-based routing strategy. In this hash-based routing strategy, we use the source IP address or the URL and we calculate a hash out of it. We have another video on consistent hashing to explain this routing strategy in depth. So please go ahead and watch the video on consistent hashing to know more about the hash-based routing strategy, right? This typically works on stateful systems. Again, stateful system and stateless systems is something that we are going to cover in the upcoming videos. So please stay tuned for that video as well. Hello, hi and welcome everyone to my new video on system design. If you are a software engineer, chances are you would have heard about terms like stateless and stateful systems. This video is a beginner's guide to understanding these terms and have practical insights about when and where to use these systems. I'm Mohit Yadav and I teach at Scalar Academy. I've been very fortunate enough to work on systems that saw over 10 million concurrent users and have built data pipelines that can process terabytes of data per day. Now let's get started. Let's say you're building online calculator and you're asked to add two numbers. Do you appreciate that every server in the system is equally well equipped to answer this query? It doesn't really matter which user is asked to do these operations. Every server in the system will yield the exact same result. The reason each server is able to do so is because the servers are not saving any context or state. This makes every server equally favorable to answer that query. Such systems are called stateless systems because they're not storing any state, context or any data in the application server. Now let's consider another example. Let's say we are trying to build a chatbot this time and one user sends a query asking for restaurants that are nearby his location. The chatbot first saves this message in the memory and then responds with a list of restaurants nearby. It then asks the same user to pick one restaurant out of the list. Now the user, let's say, choose third restaurant, and if this request goes to the same application server, it will be able to return relevant information since it has context about the previous chat history. However, if this request goes to some other server, that server will not be able to comprehend the message properly due to the absence of previous conversation history. Therefore, in such systems, the context of the conversation really matters. This context can be decoupled from the application server by simply adding a storage layer to save the messages. Such systems where the context or the state lies within the application server are called stateful systems. Now that we understand what are stateless and stateful systems, let's take a moment to appreciate the pros and cons of each system. We'll start off with stateless systems, which are very easier to scale. The reason is that each server in the stateless system is equally well equipped to handle the request. Thereby, if the load on my system increases, I can just add or remove servers in the system and my entire infrastructure will work just fine. These systems are also resilient to server failures because there is no state which is maintained at the server, and even if one server goes down, there is no actual loss of data, and the lost server we can just replace it with a new one and my system as a whole will work as expected. However, most of the systems that you will design will need to store some state in some way or the another. If you want to keep the system stateless, chances are that you will store this data or this state in a storage layer. Now, querying this data will involve a network IO call. This operation will drastically slow down your system performance because you are involving a network IO call. Reading the data from your application server will be slower as compared to doing a network call and fetching the data from the storage layer. Now let's compare this with the stateful systems. Since the context or the state of data required to answer client queries reside within the application, the latency of stateful system is much lower as compared to the stateless ones. However, these systems are not resilient to server failures. If one of the system goes down, the data that was residing in the application goes down with it. Hence, it makes sense to store either the derived data or the data which is actually very short-lived. Because of this, it is also harder to scale.
right? It is quite difficult to scale such systems because with the increasing number of requests, we will have to transfer some amount of state from one server to newly added server. This might sound trivial, but in reality, it poses many risks associated with distributed systems. You would have heard somewhere that stateless systems are beautiful and software engineers should always try to design their systems to be stateless. This is true in most of the cases, right? Because we can just add or remove machines and the load of the entire system will be uniformly distributed. However, in some cases, it is essential to store the data locally in the application server as well, especially in cases where the state is very short-lived. I'll give you one very good example. Let's say you're designing a multiplayer game like PUBG. If you store the state of a particular match in a separate storage layer, the latency of the entire system would be huge. Imagine somebody shooting someone in the game. That state is stored in a separate DB and it is propagated to multiple users who are also playing the same game and they are reading from the DB. There will be a lot of lag. Hence, the latency of such systems needs to be very low. So what we do is we store the state of such applications in the application server itself. Also, it is important to note that the state of a PUBG match is very transitive. We will not need this information once the match has ended. Hence, in such cases, stateful systems makes more sense. In nutshell, just like any other system design concept, deciding which system to go for depends upon the use case in hand.
Ever wondered how games like PUBG scales horizontally? We learned that designing a game like PUBG would require us to save the state in the application server itself. We also saw that this state is very short-lived. To understand why, let us see what information we are storing about the game. Every game will have players and each player will have to store their location on the map, their health, weapons and the team information that they are playing in. We need to store this information only till the match is live. Once the match has ended, we can destroy this particular information because it does not make sense. If we store this information in a database, we'll end up wasting a lot of time. Why? Because we'll have to query the database every time a person requests for the match state. And this is an IO call, network IO call, which will waste a lot of time. Hence, it is critical to store this information in the application server itself. Now, in order for a match to work seamlessly, all players of a particular match must be routed to the same application server. Else, they won't be able to find the relevant data for that particular match. To achieve this, what we can do is, we can assign a match ID and ask our client to send this match ID whenever they are making a request. They can send it as a path param, they can send it as a header, they can also send it as a query param. The thing to note here is that the load balancer must ensure routing the traffic based on this match ID. In simple words, if the first request for let's say match ID 2 goes to server 1, all the subsequent requests of same match ID must be routed to server 1 only. Which algorithm can we use to distribute this traffic? Well, in this video, we are going to discuss one such approach. We are also going to look at its pitfall and build intuition for the upcoming video on consistent hashing. I am Mohit Yadav and I teach in Scalar Academy. I have been fortunate enough to work on scale at Hotstar and Nutanix, where I build systems which has massive read and write volumes. One of the reasons behind doing this system design primer series is to impart the knowledge that I have gained over the past 1 decade and help budding software engineers get better at architecting systems. Now coming back to the topic. Remember, our goal was to distribute the load in such a way that all the requests with same match ID must be routed to the same server. Match ID 2, server 1, all subsequent requests of match ID 2 going to server 1. The second point was that the load should be uniformly distributed. Meaning if I have n servers, load on each server must be equal to or must be nearly equal to 1 by n. And finally,
I should be able to add or remove instances from the cluster. Why? Because that is the essence of horizontal scaling. I don't want to build an infra where I have constant number of machines. My load on the system can increase or decrease. Depending upon that, the number of servers in my cluster can increase or decrease. The first strategy, if I have to think about the approach, the first strategy that comes to my mind is that I have a match ID, and if I have to route traffic to each of the servers evenly, the basic strategy that comes to my mind is that I can simply take a mod of match ID with the number of servers, which is n. This number will signify which server will process my request. Let's take a few match IDs to see how exactly this is going to happen if we have 3 servers running. Let's say the match ID is 11, 11 mod 3 is 2, 42 mod 3 is 0, so it will be routed to the 0th server. 34 mod 3 is 1, so it will be routed to first server. Similarly, 53 mod 3 is 1, 63 mod 3 is 0, which will be routed to 1 and 0th server respectively. We see that the above approach will satisfy my first 2 goals. Let's dig a little deeper to find out what will happen if we add one more server. Now my number of servers, or n, becomes 4. So let's consider all the examples, all the match IDs that I took in the previous case where n was equal to 3. So now since n is equal to 4, 11 mod 4 will become 3, 42 mod 4 will become 2, 34 mod 4 will again be 2, 53 mod 4 is 1, and 63 mod 4 is 3. Now let's consider the other case where we are removing one instance from the cluster. 11 mod 2, 1, 42 mod 2, 0, 34 mod 2, again 0, and 53 mod 2 is 1, 63 mod 2 is again 1. Now what is happening here? Let's consider the first case. If the match ID is equal to 11, which was getting routed to server 2 when we had 3 servers, will now be routed to server 3 when we add a new instance. Unless we transfer the data which is already residing in server 2 to server 3, our users will not be able to get the match information. And as we can clearly see from the examples that we took above, whenever there is a change in the number of servers, a majority portion of the keys will be distributed to the new servers. And this by no means is an ideal behavior. We need a way to minimize the need of data transfer whenever we decide to add or remove instances. Now before winding up, I would like to give you a home assignment. That's a maths puzzle. The puzzle goes like this. Consider initially there are m servers in the cluster and you can add or remove servers from the clusters. Let's say you do some add or remove operation and the final number now becomes n. This n can be greater than m, meaning that I have added new servers in the cluster, or it can be less than m, which means that I have removed few servers from my cluster. What you have to do is you have to write an equation using which you can find out the amount of data that will be moved. Write your answers in the comment section and we will see who gets it right. I hope you all get an idea about basic approach for load balancing in stateful systems. We will look at a better approach, which is consistent hashing, in the upcoming video.
How do you distribute the load evenly in stateful systems? In the last video, we saw one such approach where we used the modulo hashing. The approach works perfectly fine until we decide to add or remove the instances. Whenever we want to add the instances, a majority portion of the keys needs to be rehashed. In this video, we are going to look at a better approach called consistent hashing. I am Mohit Yadav and I teach in Scalar Academy. Now coming back to the topic, let's have a look at the problem statement again. Our problem statement is that we need a distribution scheme that does not directly depend on the number of servers, so that
whenever we want to add or remove servers, the number of keys that needs to be relocated is minimized. To understand the solution, let's visualize a circle with marking 0 to a very large number, let's say 10 to the power 18. And we'll call this particular ring or a circle as a consistent hashing ring. Then we'll take two hash functions which will basically generate keys in the range of 0 to 10 to the power 18. Let's call them HS and HC. The HS hash function will be used to mark servers on the consistent hashing ring. The HC hash function can be used to mark partition key or the client ID on the same consistent hashing ring. Now to find out on which server a given key needs to be routed, we need to locate the key on the circle and then move in the counterclockwise direction to find the server. Now there are two main problems with this approach. First, uneven distribution. The server which is located at the max distance in the counterclockwise direction will get the most number of requests. And the second one is the weighted routing, wherein we might have a scenario where one server has twice the number of resources as the other servers. In that case, we need to ensure that the servers with more resources gets more number of requests. To solve for the other problems, what can we do? We can assign many labels to each server. So now instead of having labels A, B, C for three servers that we had, we'll have server labels between A0 to A9, B0 to B9, C0 to C9, all marked in the same circle. Now if server B is twice as powerful as the rest, it could be assigned twice as many labels. As a result, it would end up holding twice as many objects on an average basis. This way we can be sure that the keys are evenly distributed and server with better resources are holding more amount of data. Now let's see what happens when we remove one server. Imagine that server C is now removed. To account for this, we must remove all the labels between C0 to C9 from the circle that we had, the circle which was basically representing the consistent hashing ring. This results in the object keys reassigned to server A and B. Whatever keys were residing in server C will now be reassigned to server B and C respectively. But what happens with the other object keys, the ones that originally belong to A and B? The answer is nothing, absolutely nothing. And that's the beauty of consistent hashing. The absence of CX label does not affect the keys in any way. So removing a server results in the object keys being randomly assigned to the rest of the server, leaving all the other keys untouched. And if you notice closely, all servers are still holding 1 by n amount of data. Earlier also they were holding 1 by n. When they had 3 servers, they were holding 1/3 of the data, and then when we removed one server, every server is holding 50% of the data. Now consistent hashing is used to uniformly distribute the data in stateless systems like Kafka, Cassandra, etc. It's also a very powerful tool that finds its application in the stateful servers, as well as it is a way of implementing sticky sessions in the load balancer. I hope you got an idea about what consistent hashing is, how it works.
Hi, my name is Anshuman and I'm one of the co-founders at Scalar Academy. If you are new to tech and you have recently heard the term caching and don't know what it means, then this video is for you. I was fortunate to see scale at Facebook. I was fortunate to be part of teams that build products that scale to millions of queries per second and billions of users. I'm here to share some of those learnings with you.
All right, so I'll try to explain caching as simple examples as possible. By the way, there is a bonus problem at the end of this video, so please do stay till the end of the video to look at the solution of that. All right, so let's imagine that you want to make milk tea. One obvious ingredient of milk tea is milk itself. And milk I find in most grocery stores, department stores that are around me. So one obvious way whenever I'm making milk tea is that I go to the department store, fetch milk from here, and then make my milk tea. This to and fro process, by the way, ends up taking a lot of time. However, one thing which strikes me is, by the way, I can buy a refrigerator. I can buy a fridge which stays in my house only, where I can buy few milk cartons at a time and I can store it here. And when I'm making a milk tea now, then as long as there is some milk present in the fridge, I can use it from here. If there is no milk present in the fridge, then I go to the department store and I buy the next set of cartons of milk. So what have I done in the process? I could still have gotten milk from department store. It's the same milk. However, I created this temporary storage which is close to me, which is much faster for me to be able to store those milk so that I can make my milk tea faster. Plus, then I have more motivation to make milk tea because I have it in my fridge. Very similarly, if you look at the design world, distributed systems world, you always have these systems that are looking for some or the other information, right? So machines talk to each other, they query for information. Imagine you load your Facebook profile page. That profile page would need to show your name, email ID, your friends, etc., etc. So for that, it would need a lot of information. So this machine would then ask for profile information for yours, which would be there in some other machine in the hard disk. And reading from hard disk is slow. If you would have noticed, when you transfer movies, etc., from your friend's laptop, those movies are written to your hard disk, and those hard disk writes are fairly slow. Very similarly, reading from the hard disk is also slow, especially if your data is lying somewhere you don't know where. So you'll have to search through the index to find where this profile information is and then fetch that data from there. However, if the same information was in RAM somehow, which is main memory, then accessing that would be faster. However, I mean, if we're talking about Facebook has so many people, so many profiles, all information cannot reside in RAM. It has to be in the hard disk, which is the same as me going to the department store every single time when I want to make milk tea. However, if I know that there are, let's say, certain profile pages that are fetched very often, that are more likely to be fetched than the other profile pages, then maybe I can create a fridge, a refrigerator, where I can store the information of these pages, so that when somebody asks for these pages, then I don't go to the departmental store, which is the hard disk in this case. Maybe I have that information in RAM or a faster memory access. I mean, let's not say RAM, some place where I can find that information faster than actually having to read from the hard disk of a different machine. That process is called caching. Caching is exactly what I did with my refrigerator to department store. It is exactly doing that to reduce the latency of fetching that information in some cases. A cache will never be as big as your total storage. There will always be cases when I run out of milk in my refrigerator, or when the information is not present in this fast storage. And that process, by the way, this is caching. And when I find data in my cache, it's called a hit. When I do not find the data because it is not present, therefore I'll have to go to the departmental store or go and read from this hard disk. That is called miss. So whenever you find data in the cache, it's a hit. You don't find it, it's a miss. That is caching. And caching is something, by the way, you encounter on a day-to-day basis. For example, you might have noticed that when you load a website for the first time, it's usually slower. But when you refresh, it loads faster. Sometimes when your internet is not working, you keep refreshing after a while, and eventually the website loads. Your internet doesn't get faster. That's not the reason why it loads. It loads because once, let's say there was an image on the website. Once that image has loaded, that means your browser has now gotten that carton of milk. So it caches that in its own memory. On your browser, on Chrome, it gets cached. So next time when you load the same website with the same image, the browser doesn't go and fetch the entire image from the other website. It only checks if it was the same image. If it was the same image, then it fetches it from its local memory, which means I don't have to go over that slow internet to fetch that image. And therefore, by using caching, I have significantly reduced the latency of fetching that data. That is caching with your browser. Systems within also do caching in various forms. One simple question I have. If you haven't seen my cap theorem video, please go and see that, because this question is slightly based off that. Imagine you are building a very consistent system. You would want that if you're doing caching, then this cache data is exactly consistent and exactly the same as the data present in your hard disk for whatever entries it has. If you're building a consistent system and you're doing caching there when I ask you to update, how do you go about updating such a system? In the context of the departmental store and milk tea example, let's say that you want your milk tea to always use the latest milk that is present in the department store, or always use the milk that is present in the department store. How do you validate that the milk that you have in fridge as of now is exactly the same milk that is present in department store? How do you do that? There is something called as, well, actually, if you look at how you would do it, there are only two ways of doing it, right? One is when you tell me that, hey, here is new milk to restock your store with, or here is new data, right? Which is, let's say, and on my profile name, for some reason, my name changes. So whenever there is data pertaining to me that is being updated, it does not go directly to the hard disk. Imagine this is my hard disk or hard disk storage, and here is cache. Whenever this update operation comes, it goes through the cache. So first I check, is this entry present in the cache, which is my name, is my profile cached? If it is cached, then I first update the entry in the cache, and then I update the entry in the hard disk. And only then, when both of them have been updated, only then I return success. This is called write through cache, which means whenever new milk comes to the department store, it goes through me. It goes through my house. I do a verification, and only then I let the milk pass. That is write through cache. Or the other way could be that if the database is aware of where my caching system is, whenever there is a profile update, the database tells cache to throw away whatever information I have regarding my profile, because that is now out of date. And only once invalidation has been done, only this write has been done, invalidation has been done, only then you return success. Or in the context of, again, departmental stores as well as milk, let's say whenever my department stores gets a new kind of milk, they call me up and they say, hey, look, please throw away the milk that you have in your refrigerator. It is old now. We have a newer quality of milk. And that way I make sure I'm always cooking my milk tea with the newest quality of milk that I have in the market. That way I stay consistent. That was all for me for today. I hope, again, caching made sense to you. You understood why caching happens in systems.
Hi, my name is Anshuman and I'm one of the co-founders at Scalar Academy. If you're a techie, chances are you would have heard about cap theorem. Today we would talk about what C, A and P in cap theorem stand for, why it works the way it does, and what does cap theorem mean in the modern ecosystem. I was fortunate to see tech at scale at Facebook and was able to design products that served millions of queries per second and billions of users. I'm here to share a few of those learnings with you.
All right, so let's first look at why do we even need to learn cap theorem. Cap theorem is one of the most basic principles of distributed storage. So if at all you think about building or working on distributed systems in the future, cap theorem is a must-have, must-know. So that's why you need to learn cap theorem. Now, before I get into explaining cap theorem, and I would try to do that with using as simple example as possible, I want to give credit to Kaushik, whose blog I have borrowed a few ideas from. So thank you, Kaushik, for coming up with a very, very innovative example. So let's get to it, right? So to elaborate cap theorem, I'll take example of a real world example of let's say you. Imagine I am an entrepreneur. I'm looking for ideas and I feel, you know what, like people need reminders. Let's build a service that just stores reminders, right? Which is, I get this very premium number. Imagine I name my company as ABCD and I get this very premium number, which is 1234, 1234. People could just call me on 1234, 1234, and they can tell me what they want to remember. And then when they call me back, I tell them what they wanted to remember, and then things work. It seems to me that this is a great idea. So what I do is I set up this line. I sit in the office. Imagine this is me. Forgive my drawing. Imagine I sit in the office. Every time somebody tells me, let's say I got a call from X, and X says, hey, please remember that I have a flight tomorrow at 9 p.m. I say, great. Next time they call and they ask me, tell me what I wanted you to remember. And then I tell them, you know what, do you have a flight tomorrow at 9 p.m.? And then this seems great. I charge people very nominal amount of money to store this information, and service takes off. Everybody needs this. There's a big market. Everybody starts using it. And then I start to hit the problem. And you'll notice most systems, they start to hit the problem when they hit scale. Then I realize that I'm getting a lot of calls and I'm not enough to address all of those calls myself. So then I start to think, and then I think, sure, let me get my wife also involved. So now this number actually has me and my wife, both of us sit with our diaries where the call gets routed to either one of us, whoever is free. And when I get a call, I just very quickly, if the person is asking me to take a reminder, I just take down that reminder, right? And when the person calls me back, I respond back with the reminder. Great. I have suddenly now doubled my capacity. If I was able to take 1,000 requests in a day before, now I can take 2,000 requests because I have my wife to help me as well. Very soon, I got my first unhappy customer. Mr. X calls me one day and says, hey, can you please remind me when is my flight? And I look through my diary and I realize I don't have an entry corresponding to Mr. X. And I tell Mr. X, hey, look, I don't have an entry corresponding to you. Mr. X seems very disappointed, very angry, and then disconnects the call. Now I start to think, what might have happened? Either Mr. X was delusional, or maybe there was a fault at my end. And then I see that there might have been a problem. It is possible when Mr. X wanted to store their reminder, they might have called my wife. And my wife would have stored this entry that, hey, X wants a reminder for a flight at 7 p.m. tomorrow. However, that entry is not with me because that call never came to me. However, when X wanted to understand when their flight was, they ended up calling me instead of my wife because they don't know. They only know this number, 1234, 1234. And I don't have that entry. And this is why X is very unhappy. This is what is called as consistency problem, data consistency problem, which is an end consumer might have stored some data with me, and when they ask me back, there is no guarantee that they will get the data back because it depends on where the request comes to. If the request comes to my wife, they'll get their data back. If the request comes to me, they'll not get the data back if my wife's diary has that entry. This is a big problem. If not solved, my company will die. So I start to think, and I come up with a solution. I say, hey, look, here is what we could do. When X calls me to say that, please note down that I have a flight tomorrow at, imagine 6 p.m. I'll note it down in my diary. I'll also tell my wife to note down this entry, which is also that tomorrow 6 p.m. flight. And only when both of us have written the entry in my diary, in their own diaries, then I return success. Then I tell Mr. X, I have noted down your entry. That way, there is guarantee that both of our diaries, my diary and my wife's diary, they'll have the exact same entries. Consistency of data. They'll have the exact same entries. And great, my consistency problem is solved. Now, when X calls any one of us, we can respond back with the right data points. Things were going great. One day I again start to face a problem. One day my wife calls in sick. She's not keeping well, so she's not in the office. What that means is that my wife, for the time being, is gone. For a day is gone. And at that very moment, this another gentleman Y calls me and tells me to note down an entry. I say, okay, sure, what's your entry? And they tell me, you know what, I have a flight tomorrow at 3 p.m. I say, great, let me note it down. Let me, by the way, also go and tell my wife to note it down. Oh, by the way, my wife is not here. She can't note it down. And therefore, I'll have to tell Y that, hey, I can't note down your request. Your request actually has failed, which means for the entire day, I can't take in any new requests. That is a availability problem, which is my system is not available to take all kind of write requests. In the case of software systems, for example, like Facebook, you could think of Facebook saying that for an entire day or for an hour or for a few minutes, you can't make any new posts or you can't post any new photos on Facebook. That is an availability problem. So again, I'm very stressed. What do? I don't want my business to fail. So I think and think and think, and I come up with another solution. I say, you know what? When my wife is not here, so I have my diary. And imagine my wife is not here, so I have written a bunch of entries. This new day comes. Whatever entries I get, Mr. X says to note down something, I'll note it down. When Mr. Y says to note down something, I'll note it down. And when my wife returns back, because I want both of our diaries to be identical, I tell her, look, you'll not take up any phone calls till you have noted down all of the additional entries that I made in the previous day. Or if she was gone for last 2 days, then in the previous 2 days. So you first note down all of the additional entries and then you start taking calls. And then my problem is solved. Now, because if X calls me and says that, please note down that I have a flight tomorrow at 8 p.m. Even if my wife is not in the office, I can still note down the entry and therefore I'm still available. Since my wife will come back and she will actually catch up with whatever new entries are there in my diaries before answering any phone call. So we're also consistent, which is great. Things are going super good. And then comes another problem. One day, me and my wife, we both have fight and we stop talking to each other. So imagine I get a phone call, X says, hey, look, please note down, I have a flight tomorrow at 9 p.m. I can't note it down because I'm not able to talk to my wife. And if I note it down, then and tell X that, hey, look, I have noted down your entry, then my system becomes inconsistent, right? Because my diary has now different entries, my wife has different entries, and she's still taking calls. So when this network partition happens, where I'm not able to talk to my wife or other systems, then I have to make a choice. Do I want to stay consistent or do I want to stay available? If I want to stay consistent, then if Mr. X calls me and says, please note down the entry, I will have to say, sorry, I can't. My system is down. It's not accepting any new write requests. If I want to stay available, then I can take down the entry, but then I become inconsistent. So if I choose consistency, then I become unavailable. If I choose availability, then I become inconsistent. And that is exactly the CAPS theorem. CAPS theorem says that if you have consistency, if you have availability, and if you have partition tolerance, then at a time you can only guarantee 2 out of these. You can't promise all 3 at the same time, which means when this network partition happens, I would have to choose between consistency and availability. I can't have both. That's the CAP theorem. Now I have 2 bonuses to add here. Most systems that are available and partition tolerant, which is called AP, A for availability, P for partitioning, C for consistency, right? Most systems that are AP can still make sure that they become eventually consistent. What does that mean? That means eventually my and my wife's diary, they have same entries. How do I make sure of that? Whenever we start talking again, we can exchange notes. Or maybe just imagine that there's a clerk here that I've hired who just takes up all of the new entries in the last 1 hour, tells me what those entries were, so I take those down. Also, by the way, asks me what were the entries that I made in the last 1 hour, goes back to my wife and tells, here are the new entries that were made in the last 1 hour. So there might be periods in between that I was inconsistent, but eventually we become consistent. So that is eventually consistency. There is one more extension to CAP theorem that was done very recently, actually not very recently, about 10 years back. which is called as PACELC theorem. And what this theorem states is that, hey, look, when network partition happens, when my systems can't talk to each other, then sure, you have to choose between availability or consistency. You can't have both. However, there are going to be cases when my systems can talk to each other, which means there is no network partition, which is else. So else, I have to choose between latency or consistency. I can't have both. If you notice, when I made this decision that to stay consistent, I will make sure that on every single call, I will make sure my wife also notes down the entry and only then I return success. Then I'm actually waiting for my wife to note down that entry. My wife could be doing something else at that time. My wife could be answering some other call. And in that case, the entire request might end up taking a lot of time. So the latency could become high because I want consistency. However, if I was willing to let go of consistency, which is I wanted to say that, hey, look, I'll just note it down and maybe my wife could probably catch up later on, then latency could stay really low. So then you would actually have a balance between latency and consistency when there is no network partition. So that's what PACE-LC theorem is, which is just an extension to the CAP theorem, because CAP theorem does not talk about latency. I hope that made sense to you, and I hope that was helpful. This CAP theorem is one of the most basic and one of the most useful theorems you'll come across when designing distributed systems. I'll keep doing more videos like this. If you like this video, please like the current video and subscribe to the channel. Thank you. Thank you so much.
Hello everyone, welcome to this session on system design. Primarily objective of this round is to help you guys tell you about what kind of questions you can expect in system design round, and more importantly, how do you answer in a particular system design round. So we'll take one example, we'll discuss one framework around what should be the ideal framework around discussing such questions. All right then, let's get started. So the agenda, first let me give you a brief about why these system design topics are important. They have importance in two areas, right? One is your ongoing job and the other one is the interviews. So whenever specifically it makes sense for people who have higher experience, right? People who are coming from, let's say, 2-3 years of experience, they are expected to have some knowledge about system design, right? So system design encompasses two main components. One is the low level design, wherein you'll be expected to either write the schema or maybe design the APIs or maybe design the class, like what are classes and interfaces, how would you design that particular code. And the other one is having a broader perspective of how different components are going to behave. So typically to have you'll basically get around 1 hour or maybe some more time to discuss a particular system in detail during your interviews. So it's best to follow this particular framework. I have followed this particular framework for Facebook, and I was able to crack Facebook with this particular framework. And whenever you apply also, your recruiter will also tell you about the same framework that I'm going to be telling you. So without wasting more time, let me just introduce the framework to you guys, and then maybe if you have any questions, you can type it down in the comment section. I'll read the questions from there, right? So the framework has 5 steps. It's a 5-step framework. You always start with gather requirements, right? So your first step should be to gather or ask clarifying questions about the requirements. Most of the time, I'll give you side by side, whenever I'm giving you the framework, I'll also give you one example and correlate how, if for this particular question, what should be the ideal answer or ideal output. So let's suppose I'm asked to design a URL shortener, right? Let's suppose I appear for a Facebook interview and my interviewer asks me that, hey, you need to design a URL shortener. Now, this by itself will basically give you some hints about how you should typically approach the problem. Even if the problem is 100% clear to you, you must ask some clarifying questions. Most of the time, the problem will be vague enough that you will have to ask clarifying questions. But even if the problem is crisp, clear, just reiterate the problem in the same, in your words, so that you and the interviewer are on the same page, right? So gather requirement step will basically, for example, if I'm asked to build a URL shortener, For me, the requirements can be, do I need to add personalization, or do I need to add support for analytics? Do I need to support things like expiry of a particular long URL? If somebody uses my service and I give a particular short response, for how long should I persist that particular short URL to long URL mapping? That is also a business statement, and that will dictate how my design will look like. So it is important to ask such clarifying questions in the gather requirement phase. Now, I hope the first point is clear to everyone. Let's move to the second point, which is once you've got an idea or got a sense of the requirements that you'll be building out, just write all those requirements down on a piece of paper or Google Doc or anywhere, right? If you're doing it on a whiteboard, you write the requirements, freeze the requirements on the whiteboard. It is important to note here that do not spend lot of your time on this particular part, gather requirements part, maybe 1 or maximum 2-3 minutes on this particular aspect. Right? After that, you need to spend time on estimating the scale. Now, there are multiple subsections to estimating scale. The sense or the idea that I'm trying to get out of estimate scale is, now this is also one more area, just like gather requirements, your interviewer will work with you to basically give you the requirements. You'll give certain assumptions, the interviewer will say yes or no, right? Or maybe you can ask question to the interviewer and he'll give you the answer for that. For estimate scale also, for example, if you don't know what your starting point is, just ask how many daily active users are going to be there. So for example, I was asked to design a URL shortener. I asked my interviewer how many users are going to use it, or how many daily active users are going to use it. So let's suppose my interviewer said that there will be 1 million users, which I can expect to use my service. So in the estimation scale step, what I need to do is I need to convert this 1 million daily active users to find out how much storage is going to be required to convert these 1 million daily active users. Now, my interviewer also tells me, or I tell him that, hey, I am assuming that 90% of my users will just read the data and only 10% of the users will write the data, right? Now, this is one assumption that I'm making. I'll express this particular assumption to my interviewer, and based on whether he says it's a fair assumption or not, I'll change these numbers. But for our system, let's suppose these are the numbers. So 10% right means that 1 million into 10%, which means around 100k users are going to write something are going to generate data on a daily basis. Now, what is the data that these guys are generating? These guys will give me the big URL. I'll have to somehow do some transformational magic here and return a small URL in return. This big URL can be, let's say, 100 characters, and this short URL can be 10 characters, right? So this is the kind of transformation that I need to do. Let's suppose to store the entire record, I can store it using 1 KB of space. So what is the daily space that I'm going to need? The bare minimum daily space that I'm going to need for my system, it will be 1 KB of data for one record, because one record is taking 1 KB, multiplied it by the number of users that I'm getting who are generating the data on my website. How many such users are there? There are 100k. So this is 10 to the power 5, which is something around 10 to the power 5, 3 MB, around 100 MB of data, right? This is on a daily basis. So Bhagyarana says that it should be 1 million into 10 to the power, into 1 KB. It won't be 1 million. The reason it will not be 1 million is because only 10% of my users are generating that particular data. Not all of them are generating the data. The people who are generating the data, that means they're using my service to shorten a particular URL. Only those users will be considered. Hence, I've taken 100k users, right? Which basically means that I will be storing around 100 MB of generating around 100 MB of data. And if I have to calculate for a particular year, then it will be 365. I'll have to multiply it by 365
which would be around 3.65 or 36.5 GB of data. Right? On a yearly basis, my service is going to be producing this. Why am I not taking the read into consideration while storage? Because I'm only storing whenever you are a person is requesting a shorter URL for a long URL that I've got, only then I have to store that particular URL. What happens when a person wants to read that particular URL to a big URL? If a request comes for reading this particular URL, I'll go to the storage, I'll read whatever is the corresponding big URL, and I'll return it back to the user. So in that, I don't need any storage, right? So the second step, which was estimating the scale, the most important thing is to estimate how much storage you are going to require. Because this number, this 35 or 36 GB number that I've got here, tells me that only one instance can basically hold this particular data. The entire data for 1 year can fit into one machine itself. If this would have been around 1 TB or more than 1 TB, I would have required multiple machines to store that particular data, and hence I would require more. Since I require more machines, I would require some sort of a sharding, right? But in our case, we've seen that it is just around 36 GB of data. One instance can handle it. There are still problems. We'll come to what are the problems. But I'm just giving you what are the numbers that we need to take care of, right? So coming back to our important parameters for estimating scale, first was the storage. The other important parameter is to identify the TPS of your system. That means how many requests are you getting per second? That includes of write TPS. Write TPS would be that a person is giving you a long URL and you need to return a short URL for that. A read request in this scenario would be a person is giving a short URL and you have to return a long URL. So you need to find out the TPS of every system. TPS, the full form of TPS is throughput per second. People call it QPS as well. QPS is query per second. Some people call it reads per second, writes per second, and bifurcating it. Basically, the crux is that you need to find out what would be the number of requests for reads, what would be the number of requests for writes. Because if these numbers are also very high, let's suppose you are getting 1 million reads per second, that means that you need to have some sort of a caching enabled, you need to have some replication enabled, because one server will not be able to cater to 1 million IO calls. So there is a network bandwidth limitation as well. This is the reason why you should estimate the TPS as well. I hope that makes sense. Now let's move to the third important part, which is once you have estimated the scale, then you look for what are your design goals. What should you solve for in this particular problem? Design goals, if I have to just give you an idea about what typical design goals are. If you have not heard about CAP theorem, just go to our YouTube. There's a playlist on system design. Go to that playlist and see all the primer content. So there's a theorem called CAP theorem, which states that either in a scenario of a partition tolerance, you can only have either consistency or availability if you're taking the partition tolerance into account. So one of the design goals is to identify whether you're designing for a very consistent heavy system, or are you okay with eventual consistency and you prefer availability on that particular scenario. So identifying that is one part. Let's talk about the case that we are building. Do we need at most consistency? If I just have to explain consistency in 2 lines, consistency states that if there are 2 data nodes, let's say there is data node 1 and data node 2. Now, if the value of x is, let's say initially x is 5 in both the cases, then I get a write request which basically updates the value of x to 15. And let's say that particular value was written in data node 1. Now, if I fire a read request, depending upon whether it is going to data node 1 or data node 2, 15 or 5 would be returned. In a strongly consistent system, we'll get 15 as the response. In a weakly or in an eventually consistent system, I may get 15 or 5 both, depending upon whatever is the output. So do I need at most, do I require my system that every node, every data node in my system should have the exact same data? The answer is no, because there are very less updates. I'm just adding whenever I
generate a big URL. Once it is copied, once it is added into the database, I'm not modifying it. So either the date value will not be there, or if the value is there, it will be same for all the cases. Right? So I don't need consistency. I can live with eventual consistency. Do I need availability? I don't want, if I've generated a particular URL and I've sent it to millions of people. Let's say it was a Google I/O event, or maybe Donald Trump, or maybe Modi ji giving some speech, and to that link to that particular speech, I have let's say shortened it using my service, and I've sent it to multiple places. If those people are not able to reliably see the output, or reliably able to access my service, in that case it will be a massive hit on my website and the credibility of my website. Hence I cannot let go of the availability part, right? So design goals mein, you need to identify this, that whether you need consistency or should you prefer availability. In case of a partition tolerance we've seen, we most of the cases, you would require some sort of a partition, right? So that was my third part, having the design goals. You first identify what trade-off you will have, consistency versus availability trade-off. And the second trade-off is between latency, right? What is the kind of latency are you looking at? So let me just write it down, and then I'll explain what latency means. Now, different systems would have different requirements for having different requirements for latency. For example, the URL shortener one that I've given you, if I give you, if somebody types a shortened URL into the browser and then tries to access the bigger, URL, if that particular takes time, if the lookup itself takes a lot of time, it will not be a very good indicator on the website, because let's suppose it was basically a URL representing one particular event. Now, it's not a very good customer experience if they're just spending on the resolution time, right? I'm further slowing down the service of the end provider. So since I don't want that, I need the system to be very low latency driven, right? But it is not like people might think that we would need such kind of latencies in every scenario, but that is not a case, right? All the batch systems, for example, if you build, that can have higher latency. When you sign up for Netflix, for example, it asks you that, hey, what are your choices? Do you like to select some movies that you like watching, and based on that they give you some recommendation on the once you open the Netflix homepage. Now the same thing happens with Spotify as well. For those systems, the latency can be high. Like it is still bounded by some seconds, maybe 10 or 15 seconds, but it's higher as compared to just signing up on Netflix. You enter your email, you enter your password, and you're done. So depending upon the system you are building, you might have varying level of latency, and by varying level of latency, you can decide whether you want to build a system which is a batch system, or do you need a real-time processing system. So I'm taking a very simple example, but I hope you are getting at the point that using the same methodology, you can solve really complex problems as well. By the way, if you are interested in a very complex problem also, we take master classes. Those are free, completely free. You can join us in one of the master classes. It's a slightly longer format, hence we get to pick up slightly difficult topics than designing a URL shortener. So if you are interested in let's say building YouTube ingestion pipeline, that is going to happen tomorrow, right? So you can attend that. I'll be taking a YouTube, how does YouTube delivers its data to millions of customers which are globally distributed. I'll take a session on that on Sunday, so you can attend such kind of sessions. That will have a little more complexity as compared to what we are doing right now. This is the link for the masterclass. So anyone who's interested can attend the masterclass on Sunday. It happens on Sunday 5 p.m. Right? There will be a couple of more master classes which are listed. We take master classes on data structures as well. We take master classes on the system design aspects as well. Cool. So coming back to our original problem, coming back to our original framework. So we have discussed the design goals part of it. The next part of it is the So before I tell you about the next part, how do you typically build a system, right? You don't, for example, if you have to run a marathon, you don't, directly participate in a marathon. You maybe start to walk for a longer distance, and then maybe you start building up stamina. Then you run 5 kilometers, then 10 kilometers, and then maybe you run for a 42-kilometer marathon. Similarly, in a system design concept as well, whenever you're designing a particular system, assume that everything, right from your storage requirements, your TPS requirements that we have identified in the step 2, all those requirements can fit in a single machine. Why do we make this particular assumption? This assumption is made because if you keep everything in a single box, that means you can have any kind of flexibility. The only thing that is reduced now is all the problem is or all the data can fit into single machine, which means you can use RDS. There's no need of optimization or anything like that. We'll identify what are the bottlenecks and we'll iteratively build on top of it. We'll iteratively remove all the bottlenecks. So the last or the fourth point is basically you design for a single server. Whenever you're designing for a single server, you need to take care of DB schema. This is our based DB schema. Don't directly jump to any NoSQL system. It's a major red flag, right? So even if you have worked, thoroughly on Cassandra or maybe Redis or maybe any other database, it's a red flag if you directly jump to that particular database. Always start with RDBMS based schema, right? Once you have started with RDBMS based schema, then you move to designing the APIs and writing the business logic as well, right? Now, if I have to do the same thing for design schema and do all those things for our case as well, so let's do that here. So for the let's start with the API, right? What are the APIs that needs to be there? There'll have to be a post API, which would something be like shorten, and in the body I can get the URL and expiry, right? This would be the body. This is one API. The second API is basically a get API. Get is nothing but slash whatever is the short URL, and then there's no body in get, and you give long URL as the response. So these are the two main APIs that needs to be there. I won't spend much time into how we design that. That's a separate topic in itself. How do you design REST APIs? What makes URL RESTful? What does not make a URL RESTful? All those things we'll consider later. Like that's a topic of discussion for a different session. I won't go into that. Then you have to design the schema for this particular problem. The schema for this particular problem is a simplistic one table schema. You can have something like a short URL, you can have a long URL, and you can have validity, which user generated this, and maybe created at, and maybe some other 3-4 other tables. But the main columns are short URL and the long URL and the validity. Right? These three columns are the main columns. Using these three columns, I can answer both the APIs that I have listed out. Right now, I have done just a quick checklist. I've made the DB schema. I've made the APIs. The only thing remaining is using what should be the business logic. Now, if you think about the business logic, this problem can be solved in variety of ways. Right. One of the way to solve this particular problem is to have one ID field here, right? This ID can be an integer, and whenever you store something inside a database, that ID will get automatically generated, incremented to be precise. So it started with 1, 2, 3, 4, 5, whatever is the number, that is the shortened URL, and that will not go beyond. We are generating only 100k users per day and some 36 GB of data per day, which means that your shortened URL will not go beyond a certain limit, right? It will not go beyond 6 digits or 7 digits or maybe 8 digits, right? Whatever big URL you're getting, you just return the ID and that will be the shortened URL. But that is not a good approach, right? I hope everyone can realize that it will not be a good approach if you just rely on the database auto-generated ID. Why that won't be a good approach? Because that's easily guessable. So if I have, for example, I used your API and I used your API to generate a small URL, and then what I did was I just you returned me 54. That is telling me that hey, there are 53 other entries already present in the database as well. So I can just query using 52, 53 and find out who all are using your services. So it's easily guessable. So that's out of picture. The second approach, so first approach was basically relying on auto-generated ID, right? The second approach, which I think Rahul has also pointed out, is around using the UUID or maybe using the hash function like MD5 or SHA-256 and things like that. By default, we cannot use UUID. Why? It's a 32-bit character. Essentially, we don't require anything like this. Why? Because it is generating 32 bits of characters. I don't need 32 bits. MD5 also is 32 bits. SHA-256 is 256 bits. I don't require these many characters. Why? So let's look at how many numbers I can generate with one single character, or how many URLs can I store with one single character. With one single character, I have 26 choices of alphabets plus 10 digits, 0 to 9, 10 digits. So around 36 choices I have only with alphanumeric characters if I use it for shortened URL. If I also include the casing, I'll also introduce another 26 characters, which makes the total tally to 62. So with a single character, I can represent 62 big URLs. So let's suppose my big URL was this. I transformed it and I said that, hey, I will represent this big URL with A and I'll store this particular mapping to in the database, right? Now, how many URLs can I store using two characters then? The first 62, the first character can represent 62. The other character can also represent 62, right? So it will be 62 into 62, which is equal to 62 raised to the power 2. How many for with 3? 62 raised to the power 3 and so on. How many with n characters? 62 raised to the power n. So even if I have 5, right, 62 raised to the power 5 is I think somewhere in millions or billions, which will do my job. In case I need more, I can add one more, 62 raised to the power 6 probably, and I will get my response. I will get my final. So Shivans Dubey says it will be 62 into 61. No, I can use A and capital A again. So for the other character also, I have the exact same. Repetitions can be there. Anyways, in either of the cases, 61 or 62, that really doesn't matter. What I was hinting or what I was approaching from this particular discussion was that there'll be exponential number of combinations that I can create with a limited set of characters. So I have solved one part of the problem, right? The part of problem that which all characters or what should be my business strategy to come up with to represent million or a billion long URLs. That I have really solved. I've solved for that. What I've not solved for is the guessability factor, meaning that if I have if I return someone AA or maybe a AB, right? Let's suppose I return AB. This really tells me that there has to be a URL generated with AA. So what can I do to remove this guessability factor? Any thoughts on that? How do I remove the guessability? So what I can do is I can generate multiple messages with, or I can pre-compute all the numbers, right? I can pre-compute everything, and then I pick up the first million and then push it into a set, a hash set. A hash set will just randomize it, and then I can just iterate on the key set. Once I have accessed a particular code, I can save it in the database. That will basically ensure that my, that will basically ensure that guessability factor is removed and it is scalable as well. So that was my point number 4. How do you design system that can work in a single machine, right? Design for a single system or for a single server. Now, to add scalability factor, we need to, what can be the bottlenecks? That one server is not enough to cater to my high read TPS. In that case, what can I do? I can have multiple servers who are running this piece of logic, and each server is responsible for, each server is basically responsible for generating its own version of code, right? So I can say, let's suppose I have running 26 servers, or let's suppose I'm running only 3 servers, server 1, server 2, and server 3. I give 1 million pre-generated coupons for this one, 1 million to this, and 1 million to this, right? So as and when I'm adding new servers, I'm giving this 1 million set of pre-generated codes that can be used by that particular server. While assigning this 1 million coupon codes, I can ensure that there is no collision. Once these codes are residing in the memory of the server, I'm not introducing any new latency, and I'm ensuring that the data, I have designed a low latency system that can scale to millions of users as well, right? So that was the basic idea, right? You go for first 4 steps. You gather the requirements, you estimate the scale, you find out what are the design choices or the design trade-offs that you need to make. Once you've identified that, the next step is to basically design your system that can work on a single system. That will involve writing some DB schema. That will also involve writing APIs and also finding what is the core business logic that we should support, right? Once that is done, then is scale for the numbers that you have identified in this step, estimate scale step. How do you basically scale for whatever you have decided? Once you have discussed all the approaches and all the problems, then you go back to the gather requirements, the MVP stage. In the MVP building stage, you have written some requirements. Just go through each requirements one by one and validate that whatever you've written is working fine, and all the features that you've discussed earlier are taken care of, right? So this was the basic idea. Now let's jump into the question, and I will stop the screen share. Yeah, so he was asking that while I was estimating the scale, won't I consider the read ones as well? Because there were the number of users who are doing the read and the number of users who are doing the write operations are different. Hence, I think the question came that read ones should also be stored. I think that is not required, because whenever you have to write something to a database, only that amounts for the storage. Read once you'll consider while calculating the TPS or throughput on your system. Then you'll basically have to consider the read request as well. His another question was that expiry of URL, would it be 24 hours, 1 week, availability must? So that's a valid question which you should definitely ask when you're appearing for interviews. I didn't clarify while I was designing it, but I had taken the expiry from the client itself. Whoever is generating the URL can typically tell me that when is it that he wants this particular URL to expire. By default, I can have some, keep the link open for maybe years, but you should have a fixed expiry to all the, whatever you're adding in the database. And this is a very key concept if you think closely about it. Expiry can save you from adding or having to add multiple, shards as well. Why? Because if you don't have expiry, your data will keep on growing, right? It will go on a linear scale or exponential scale depending upon how people are interacting with your service. But if you truncate older data, that means your same single database instance can serve the request as well. So that is actually very important, that you clarify with your interviewer that what is his expectation out of the expiry. Most likely, if he asks you to design a URL shorter, even expiry will not be a explicit ask right? This is something that you as an interviewee should have, clarity on. You should ask that particular question, right? Cool. Batch versus stream, when to use, right? That's a very interesting question. I think it actually depends on your use case, right? For example, in some cases, batch processing does make sense. I'll give you one example, right? For example, ClickBuzz. Let's suppose we have a website like ClickBuzz. Now, ClickBuzz have started, let's say, one game wherein people can play or people can chat live during or comment on anything while the match is going on. After the match is over, they'll find whatever or whoever has the maximum number of like on a particular comment, they'll reward that particular user. Now, in this case, either you have both options. Either you can stream all the comments that are coming and then have an aggregate on number of likes each comment is getting, or since it's a one-off activity after which is supposed to happen just after the match, you can also use a batching system here. I would use a batching system here solely because it's a activity which will happen only after the match, right? If you see IRCTC website, that goes down after 11:30 p.m. every day. That is because they want to reconcile everything. It's a batch process. The salaries, for example, are a batch process. Where I would need a stream, I think a stream processing engine would make sense. For example, if I want to do some cloud deployment and I want to check whether in real time are there any security anomalies in my cloud deployment, right? Or for example, any kind of an audit that I want to maintain, right? For example, if somebody launches a EC2 instance and he has attached a public IP to that particular instance, that is an opening into my VPC cloud, which is a security threat. And ideally, I would want to catch it in real time. So over there, I would go with a stream processing engine because I want to have a live action defined for every outcome that is happening. Right? Okay, I think that's a very good question. His question was when I was defining the schema, right? When I was defining the schema for my URL shortener, I didn't add ID. ID I added later only when I was, going to the business aspect of it. But a quick yes or no in your mind, just keep a yes or no in your mind. Do you think a primary key is required in this case? Let's talk about yes and its implication of having a external ID. If I have an ID internally, all the MySQL or RDBMS system, what they do is they sort the data physically based on ID. So ID 1 will be placed closer to 2, will be placed closer to next to 3, will be placed next to 4, and so on. So this helps in fast retrieval of data because they are able to look up for that particular key in a very fast manner. Now, my primary lookups, I have seen this many people doing this, that they just add ID for the heck of it. There is no real use case of it, right? For me, my ID is most of the time my requests are going to be short URL. Given a short URL, what is the end long URL? That is going to be the reads. To optimize for that, I'll keep the short ID as my primary key. It is unique, right? And I want the data to be fetched using that. Hence, having an explicit auto incremental or any kind of other ID is not required. Just having a short URL will serve my purpose. So if you want to go deeper into it, just read about locality of reference. It's a very important concept, primarily used in DBMS systems. So you can typically go ahead and look into that. UUID, Hashbase, and all those systems does not work solely because they generate 32-bit numbers. And let's suppose I skim the last 5 or last 6 also, then also there'll be many chances of collisions. So dealing into those areas will just be problematic. Pseudo random number generators. So for anything that you're doing with randomness, right? Either the range has to be a lot, meaning, for example, for 32-bit number MD5, that is basically a good enough hack to generate a 32-bit unique number, or I can go with UID and generate a random number. But if my range is limited, now
let's just to give you an example, let's say I have only two numbers, 0 and 1, and I ask you to generate a random number between 0 and 1. You generated 0. Let's suppose the first number that you generated was 0. I again ask you to generate a pseudo random number. Let's suppose again you generated 0, and again I ask you, and again 0 was generated. Right now you just have one number remaining, and there are chances of there are many chances of collisions. There are 50% chance of that you generate the number which was already generated before. Now let's increase the range of your numbers. Now you have 0, 1, 2, 3, 4 numbers, right? Let's suppose 0, 1, 2, these three numbers are already generated. The probability of generating a new random number which has not been used earlier is just 0.25. 75% chances are there that you'll generate the number which is already generated. So as you keep on exhausting the available resources, the operation which was already O1 operation is basically tending to ON, right? You can take n chances to generate that particular number. If you have 100 numbers, the probability of one number getting picked up is 1 by n. So if you have out of the first 100 numbers, you've filled up 99, the probability of generating the number which is not used randomly is very, very less, right? So it's 1 by 100th. So you have to take 100 tries, then find out that particular number in a best case, in a probabilistic kind of a case scenario. So that's not a very good way to find it out randomly. Randomness helps you in some cases, but randomness is not a good enough criteria. So you can search for this particular problem. It's a very famous problem asked in interviews as well, asked in coding interviews as well, that if you have one array and you want to pick up random indexes in an equal probability. So let's suppose you have numbers from 1, 2, 3, 4, 5, 6. Out of these 6 numbers, you want to give equal probability to each number and find out and generate a random number out in this. How would you do that, right? The standard way of doing that is you always generate a number from, since you had 6 places, you generate a random number from 0 to 5. Whatever is the index, let's say 3 is picked, you swap 3 with the last element and you decrement the range. Earlier, the range of finding out the random number was 0 to 5. For the next iteration, it will be 0 to 4. For the next iteration, it will be 0 to 3, and so on. And you keep on swapping the index of element which is getting picked with the last value. How is the server assigned a set of million records out of all the possible records? I think I have discussed this problem very briefly. You can generate all the sequences, first million sequences, then second million sequences, and third million sequences. Whatever is the sequence that you've generated, put it in the hash set. Hash set will automatically rearrange the keys, right? It is not a list typically keeps everything in order. If you put it in a hash set kind of a data structure, it will automatically jumble up the records that you're getting, and that will basically ensure that you're getting a random ID every time. Batch processing would be Amazon order, salary, stock market, yes. Stream processing, live sentiment analysis. Sentiment analysis also can be done using batch processing. Might not be it actually makes sense if you want to triage or maybe alert or mark as misinformation on Twitter or Facebook these days. So yes, you can use sentiment analysis, which can be a stream. Let's take this question. He says, if we are pre-assigning the short keys, won't it be time taking for searching available key to assign as if we were trying to create on a particular second? No, so let me explain this process. Let's suppose these are my available slots. Now, what I need to do is, whenever a request comes, I need to pick one number out of it randomly, right? And assign it to the incoming request. This is stored in memory. In memory meaning this is stored on the same server on which my application server are running, right? So let's suppose the first request comes and I generate the random number. The random number which was generated between 0 to 6. I generate a random number between 0 to 6, and that returns me 2. So what I do is I return 2. 2 is now assigned to the big URL. and I move 2 here, right? So 2 comes here, so 2 comes here, and 6 comes here. All right. So the new array now becomes this. Next one number again comes. So what I'll do is, now I'll decrease the size. Size is till this. So I'll generate a random number between 0 to 5. Let's suppose the number that came was 1. What I'll do, I'll move this 1 to this. I'll swap the two numbers. What will be the resultant array? The resultant array would be 5 will come here, 1 will go here, and size minus minus. If I have to generate new next random number, what I'll do? I'll take random of 0 to 5. Let's suppose 1 is generated. Now 5 and 4 will be exchanged, right? So the data will become 4 here, 5 here, size minus minus, and so on. I can just continue this. So using this way, I can, find out, generating a random number between two numbers is very easy, right? It's an O1 kind of an operation. So using this particular approach, I can find out keys, and I can ensure that the guessability factor is, is maintained to a certain extent. And how do I distribute if I have multiple? Let's suppose I just have 10 buckets each. So how do I distribute? 10 buckets means that one server, let's suppose, can handle only 10 keys. How do I distribute them? I have a list of 200, URLs that can be generated. I pick the first 10 and I send it back. I save this 10 in the first server. That is how I can ensure that each server has 10 keys to work with. All right, guys. Thank you so much, guys, for joining in. Bye-bye. All right, we are live. Hello, everyone. I am Mohit Yadav, and today we have with us Lokesh, who will be interviewing, mock interviewing with us. The topic for today would be a topic around system design, and I let you introduce yourself and tell me something about yourself, Lokesh.
Hi everyone. My name is Lokesh. I'm currently working as senior software engineer at Akamai. So I'm totally having 6 years of experience. So prior to Akamai, I worked at Big Basket. So currently at Akamai, I'm working as full stack developer. So I'm graduated from IIIT Newsweed in 2015. So that's it about me.
Sure. Cool. So I'll just quickly tell the format for our viewers as well. I'll be asking questions. Lokesh will be answering me, and wherever I feel that I can, add some valuable feedback, I'll probably give that feedback to you, Lokesh, and to the wider audience as well. Right. So
Sure.
instead of giving the feedback and keeping the feedback for the last, I'll probably keep on giving the feedback as and when we go around. Right. Cool. So I think there are a few users who have joined us. Let's wait for a couple of more minutes before we get started. Meanwhile, I'll also share the screen. So whenever you talk about, if there's a need to draw something on a whiteboard, I'll use my iPad to draw that particular thing for you. For example,
Sure.
if you say the load balancer, I'll draw a load balancer for you. If you say something
Sure.
other things, maybe application servers or databases, I'll draw those databases as well for you. Right.
Sure.
Cool. So let's get started. The question for today is, you need to design a Google search type ahead. How would you go about designing that?
Okay, so so basically, so if I look at the requirement, so basically, when users type something on UI, so he needs to get the list of suggestions. So in the drop down, so that's the basic requirement. And coming to the suggestions, so the first thing is the suggestions should be sorted by the popularity in the decreasing order. So the most popular should be at the top, or the most searched or most popular.
Okay.
um, so and also sometimes, I mean, we also need to take care of the muted words. So I mean, we don't want to show some pirated or some adult, so some kind of words we don't want to show, so we need to filter them. So that's also one requirement, so we need to filter them.
Okay.
So I'm just thinking, so popularity and so I think for, I mean, for this, so I'm assuming we need to display top 10 popular words, I mean popular phrases only.
So
um
let's just say top 5 would do.
yeah, okay, fine, yeah,
Top
top
5.
5, yeah, top 5 words.
Right.
And so yeah, and also the most important thing is, it should handle the typos. So if we make any typos, the user make any typos, so it should handle that. So that is one word, I mean one requirement. Yeah, so so I'm assuming this is the scope of this system, I mean,
Okay.
as per the functional requirements. um so and
Anything
so
else that you see in a typical Google search? For example, if you search for weather and I search for weather, we'll be shown different results.
Okay, you mean the informational results. So should we also
Right.
consider, is it like
Correct.
so? Okay, so that means, like, Prime Minister of India. So in the drop down, we'll get the answer for that. So you mean those
Not the
information?
answer. For example, if I type Prime, I watch prime time news a lot. So for me, the suggestion can be prime time. Let's suppose you search Prime Minister a lot.
Okay,
So for you, Prime Minister will come in.
okay, got it. So using the cookies, so user cookies or personalization. So user
Correct.
personalization recommendation. Yeah. So
Right.
personalization. Yeah, yeah, that is true. That I missed it. Yeah, that's one of the thing. And um so also we should we consider the location based search or
Yes, we can.
not? Yeah,
We
so we
can.
can.
So this is basically the first phase, right? Where we just
Yeah,
scope out that just by looking at Google search type ahead, these are the 5 things or 10 things that are coming to my mind.
yeah,
Now, to in order to discuss it in a 45-minute interview, it is not possible to go and design each and every
yeah,
feature. So we'll just
true,
limit the number of features that we are going to discuss. So I'll
true, true.
cross out popular. We definitely need to sort the result based on popularity. That's a must-have. We
Yeah,
don't have to filter words. We can assume that filtration is not required. So
okay, yeah,
this is something that we can remove.
okay,
Top 5 again. Top 5 is a primary requirement for Google search, so we need to have that. Typo handling also we can ignore. Personalization and location based suggestions are also something that we can ignore for now, right?
okay,
We may
okay,
discuss it if we have time towards the end, the
exactly, yeah,
personalization bit, right?
yeah,
So let's start with these two, popularity and top 5.
yeah. So these are the functional requirements, and coming to non-functional requirements. So basically, so the system that I want. So the first of all, I mean, if I go by cap, so the system should anyway have to handle the partition tolerance because of the network failures or any failure. So the partition should be always there. So
Okay.
and then if I want to choose, that means, I mean, basically, the scalable. So I'm actually choosing scalability to be my first priority. And also so over availability and consistency. So for this case, I actually go with availability. The reason being why I do not go with consistency is because so I mean, like, eventual consistency is okay. So instead of strong consistency, eventual consistency is okay for this system. I'm thinking why, because I mean, sometimes um, I mean, even though if we are not, so let's say we have some top 5 results, but let's say I mean, we are showing let's say the incorrect one, like in the, let's say there is a term which is top 5, but we are showing top 6, or I mean one, I mean, which is misplaced. So that is fine, like it can eventually propagate, and we can show. So that's why I'm actually going with availability and the scalability. So, and coming to scale estimations, uh, I'm actually, so first of all, the number of requests. Basically, since it's a scale of Google, I'm thinking maybe some 5 billion requests per day at the scale of Google. I'm thinking.
So how did you come up with this particular number?
I mean, so basically, I just came with random, because so obviously the request will be billions. I mean, taking Google search. So that's why I came with, like some 5 or 10 billion. So 5 billion I came up with.
Okay, a good way for scale estimation, right? This is
Okay.
I'm basically giving you feedback. A good way to do scale estimation is to look at the daily active users,
Yeah,
and then
exactly.
deduce what are your TPS and storage requirements would be, right?
Yeah.
So Google has I think close to 2 or 3 billion. Let's for the sake of calculation, let's assume that Google have 1 billion users, and every user maybe queries at least once a day, uses
Yeah.
Google search at least once a
Yeah.
day. So there will
Yeah.
be 1 billion queries uh, per day. These are the reads, and every read
Exactly.
is contributing to the write as well. So I'll leave
Exactly.
the thought here and let you continue the thought.
Exactly. Yeah. So this system is actually uh, read and write. I mean, so read and writes are equal here. So that means 1:1, and so that means, here it is 1. So we are so thinking. I mean, we are having that 1 billion requests per day. I mean, because we are having 1 billion users. So coming to coming to the storage. So I think we can leave this here, and then coming to storage. In our system, so we only need to store the queries. I mean, the words, or the queries. So for that, I'm thinking, so maybe, so each query at max may not store may not take more than, so maybe, like since they're strings, so and they actually, I'm thinking, maybe, like less than a kilobyte. So that means, like, something like um, some 512 bytes or something. I'm thinking, like half a kilobyte. So each word. So that means we are having 1 billion requests. So 1 billion into half, I mean, into 0.5 kb. So which will, I think, I need to calculate. So
This will
something,
be something in terabytes, but is that
yeah.
calculation correct? uh, because although we are getting 1 billion search queries, do you want to relook at this number? Because all of them are not unique.
Yeah, exactly. So yeah, all of them are not unique. And and in our system, we don't write them. I mean, so we don't write all of them, so we already may have other info. So that's why, I actually, so I mean, the maximum threshold. So let's say we got a word, or we got a phrase in the worst case, that is not in the system. So in that case, we have to store the whole word. So that's why I came up with, less than a kilobyte, so around maybe some 256 bytes or something. I
Okay.
mean, 0. Yeah, so 256 bytes. So at maximum, I'm thinking.
Okay. So we'll leave the storage part here. Let's move ahead. Let's just assume that one box is not enough to handle the entire storage data.
Exactly.
Okay.
Exactly.
Let's just assume that there were some issues with the storage. The issues were that you were reducing the size of the particular record. Instead, then what I'm arguing on is that you won't be having 1 billion records to write, because let's say
Exactly.
I search for Michael and you also search for Michael, that will end up going in the same direction. I'll just upgrade the frequency. But let's
Exactly.
see the design first, and then we'll come back to the storage part later.
Yeah, sure. So I'll go with the first, go with, so the basic design. So basically when we, so we can actually think of, the first thing that comes to, to our mind is, try. So I mean, to store them in a try. So it's very very trivial and obvious that, I mean, by looking at the question, so that means we have to use try. So basically, we'll have one node, and for each node we'll have, we'll store them. Yeah. Um so let me first, try, I mean, let me first go by, the flow. So basically the user sends a HTTP request, so with the votes in it. So let's say user searches with Donald.
Okay.
So as you written, so basically, I mean, initially I'm assuming that, I have only, I mean, I don't have large scale, but small system. So basically, so the client sends the request, and I actually go and look up the try. And each lookup I actually try to find. uh, so I mean, if it's a successful match, that means if it's a successful vote, so then I actually update the frequency at the terminal node. So basically, we know that in a try, we actually store a boolean called is vote to tell whether that's a vote or not. So basically, yeah, so that's a vote. So whenever it ends there, so in our case, we also store the frequency, so which will be updated incrementally every time. uh, so and
So one quick
yeah,
question over here. So you said that let's suppose the search query is Dawn here, right? And there is a null character over here as well. That means Dawn is also a valid word. So you
yeah.
suggested, let's say, two words, Dawn and Donald, and he clicked on Donald. So what all, where all? Now I think each node can have its own frequency.
So
Terminal
each
node,
node.
each node means
Yeah,
each terminal
each
node
terminal.
can have its
Yeah.
own frequency. So
Yes.
which all frequency would you modify?
Yeah. So you're saying, when user enters Devo and Don, so we'll suggest Don and Donald. So
Right.
if user clicks on Donald, so which we will increment, right?
Correct.
Yeah. So in this case, since user selected Donald, so that means will increment the frequency of Donald. So that means the D terminal node, because I mean
Right.
that's where that is getting hit. So this frequency will hit. I
Correct.
mean, however, there are still problems with this, but we'll eventually find it out. So this is the basic approach. Uh, so
So what are the
so we,
problems with it in terms of,
yeah,
so what I want is top
exactly.
five. How would I like, what is the complexity of your current solution basically?
Yeah, exactly. So here the problem would be, so when I want top five, so I actually have to traverse the whole tree.
Correct.
So that means, so let's say when I said like DON, so that means from N, so I need to actually traverse through, I mean, whatever the depth of that a tree, I mean, located at N. So I need to look them, and then I need to find the maximum of them, and then again I need to return them.
Right.
Here the problem would be drilling down the tree. So I mean, we need to find, how can we resolve it.
Right. So
uh,
first of all, first question is, how would you find top five out of, let's suppose you are doing the iteration also.
yeah.
How would you actually find the top five elements?
Okay, so you mean, so
We can do iterations. This is as good
Yeah,
as I have an array and I
yeah,
need to find top 5. So
exactly. So the main thing. And also basically when I so came across this top or I mean uh, kth largest of this, so I actually think of building heap. But again, so I'm thinking, so I mean, so can we store this information in the in each node, like, so as we build the try, can we actually store, so say at n, can we actually store the information that, okay, so top five votes at n are these, can we
okay.
actually store them? I mean,
So
so yeah.
which data structure would you use to store that?
So here I'm thinking, it would be enough if we can store the references of the terminal node. So let's say, so n at n, so d is another terminal node having some good frequency.
Correct.
So here we can uh, see here we can use a heap, uh, a max heap.
Okay.
So a max heap.
Max
So
heap.
we can,
Okay.
so the top
Are
will,
you sure that you'll use a max heap for finding top 5?
so because here we need top by the decreasing, I mean, by the decreasing order of the popularity, right? So that
Correct.
means every time I actually remove the maximum at the
Mm-hmm. I lost your voice, actually. Hello. Yeah,
hello.
now you're audible.
Yeah,
Uh,
am I audible?
yes, you're audible.
Hello.
Yeah, hi.
Hello.
Hello. I can hear you fine.
Hello.
Hello. Uh, it's a recorded session. How can you say it's live? It's not a recorded session, Sahu. It's actually live. I can hear you, man. Lokesh, hi. Hello. Can you hear me? Uh, Facing technical challenges, guys. Just bear with us for some time. Can you try reconnecting, Lokesh? I'm able to hear you fine. Meanwhile, I'll just take questions that are there. So, locations based personalized search, yes. Fast response time, yes. Hey, Lokesh, are
Hey.
you? Am I audible now?
Yes, yeah, I think
Yes.
some glitch, I mean, yeah, fine.
No issues. We are back. So we were discussing about that. You said we'll have a max heap over here,
Yeah.
right? So do you see a problem in that? I'll give you some numbers. Let's say these are the numbers: 4, 5, 3, 0, 6, 3, 6. All right. And let's suppose you want to find top 3 elements. So you
Yeah.
try building a heap. So you added 4 in the heap. Then you add
Yeah.
5. So 5 is added. Then you add 3. 3 is added. Now comes the value of 0. Should 0 be added or not? How do you decide that?
Okay.
Basically, you'll have to check
So
all the elements in the heap to do that, right?
wait a minute. So okay, you're saying, so we want top three, right? So okay. So yeah, in this case, we will check. Yeah. So basically, we need to check the minimum element to find, but the minimum is not at the, yeah, maximum is at there.
Yeah,
Okay. Yeah. That's true. So if we find three, yeah, that's true.
that's true,
So
right?
So when it came 6, so we'll check with 3. If it is greater, then yeah.
Yeah. So instead of this, what we could have is a minimum heap,
Yeah.
a min heap basically. So 4 will be there, 5 will be there, then 3 will come. So 3 comes here and 4 comes here. Then
Yeah,
0,
we can.
0 is not greater than 3, 6 is greater. So we'll remove 3 and we'll add 6. So that's how it will be done.
Yeah.
Cool. So every node will have a min heap attached to it. The size of the min heap will be 5.
Yeah.
Till that we have solved the problem. So using that, we can typically answer our query in an order one time,
Yeah.
right?
Yeah.
So
Exactly.
cool. So till that we are clear. What about what can we do after that?
Yeah. So this is the basic design.
Right.
So I mean, like I'm thinking about what else. I mean, what other problems do we have with it? So I mean, when we scale this up, so the main problem would be the storage. So like, how do we store try? How do we handle such a huge use scale? So basically, so one thing we can do is we can actually replicate the try. I mean, we can actually use like master slave approach by having multiple copies of tries. And then we can propagate, like just like how in databases. So we can write to master and then schedule to slaves. So that approach we can do. I'm thinking the problem would be so the latency would be more in this case. Like,
Mhm.
uh, so I mean, writing to so there can be replication lag, so which can add to the latency of the user. I mean the consistency can be little compromised. So this is one approach. And also one more thing is, so this is okay, like so this is okay when we can store the try in a one machine. But what about if we have to partition that, so that also we need to consider.
Yeah.
So what
So
if it
let's
exceeds?
break it down. What are the problems with this particular approach? Let's write down all the problems and then we'll discuss
Yeah.
one by one what can be the
Yeah.
probable solution. So what are the problems? Can you identify the problems and tell me what those are?
Yeah, the first problem is so I would say the data partitioning.
Uh, okay. So I'd say storage,
Yeah.
right? What else? That
Yeah,
that
storage.
entire data, the entire try that we are building cannot fit into one machine because we are storing the search, like we're storing the try of all the searches, right? So that is one problem. What is the other problem?
Yeah, so that is one problem. And should I also consider on the client side, like what issues we'll have on client or not?
Not the client side. We are designing the backend, so let's focus our
Oh,
discussion
only
on
on
the.
the back. Okay. So, and also caching. So I mean, should we have to cache some queries or something? I mean, should we implement
Okay.
caching here?
So what kind of
Uh,
caching are we uh, doing here? This is a try,
I,
right? So try would be stored in memory, so we don't require a cache.
so I mean, like, so I mean, if there are some popular things, so we can actually return, I mean, we can actually store some entries in cache, and we can write it to try asynchronously, I mean, to increase latency. Because I mean, the main requirement of the system is to have low latency to the user.
Mm-hmm.
Because if you I mean as the users are typing, it should come in milliseconds. So I mean, what if we store the I mean, like, popular ones on cache, and then we update them in the asynchronously to the try.
So if you say, how would you identify the popular ones in that case? Is basically what you're saying is
that maybe for some queries you'll save data somewhere, so that those are basic anyways the top 10 or top 100 or top 200 or maybe top 1000 queries. You'll store it separately, and whenever the term comes, you'll give the response from there. But let's focus on the main problem. The main problem is that we need to give a consistent
Okay.
response for every system, right? We don't have to optimizing for some queries. We can do it later, but let's
Okay.
optimize for the larger set of problems. So, apart
Okay.
from
Okay.
storage, do you see any other issue in this particular approach?
Yeah, I'm thinking. So, storage and so we so I mean, so main thing we need to improve is latency. So that's the main important thing so in this system. So for improving latency, I'm just thinking. So what else we can do?
So we identified. Do you think updating these top five, when we are updating the
Yeah,
frequency of a Donald,
yeah, that's
the
true.
we
Yeah.
need to update
Hmm.
D, L, all the nodes, right?
Exactly, I'm coming there. So so when we are updating the updating one terminal node, so
Right.
we need to traverse back I mean so many levels to find each terminal node and so on to till root, maybe
Mhm.
to our I mean sometimes, and we need to update this top way. So these updations are yeah, I mean are so here that's one problem.
So you said we need to update terminal nodes. I think we need to update every node that's there in the path till the top node. Why? Because even if a person has typed DO, there should be a heap
Yeah.
corresponding to
Yeah,
O,
that's true.
which can give
That's
you
true.
the node reference, right?
That's true. That's true. Yeah, yeah,
So
that
we'll
is true.
end up updating L, A, N, O, and right up to D. So for
Yeah.
one read, I am actually doing multiple write operations.
Hmm. Yeah, that's true. I mean,
And
so these.
while
Yeah.
I'm updating this, do you think a read can succeed?
So 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 you mean like so we will not so we'll not update them in sync way, but we'll do it in async way. So we'll just return the result, and we'll so use asynchronous way to update those nodes. But that still be a problem because updating those I mean, so considering the scale, the number of requests, so the updations will be a lot.
Mhm. So, basic thing, right? Let's suppose I have one database where this is a chunk of database. I have a value of x equal to, let's say, 5,
Yeah.
right? Uh, People can come and read the value of x equal to 5. There can be multiple
Yes.
read threads that can come and read this particular value. Now, let's suppose
Exactly.
there is one thread which is trying to update this value. It wants to set the value of x equal to 10.
Yeah.
Unless this value is written, all the read threads will have to wait. They cannot read this value
Yeah,
of
that's true.
x. That's true. So if I have to
Yeah.
update the value of all the nodes, till the time I will not be able to serve the reads as well.
Yeah, right. Yeah, that's true. That's true. Yeah, I mean, so in that case, yeah, Reese has to wait till these are harm. That is true. Yeah. So.
So
Hmm.
my problem is how to make this a read intensive. It's
Read.
a read equal to
Yeah.
W kind of a system. I want reads should
Yeah.
be greater than W, much greater than W. What is a way to do that?
Okay. So to optimize reads, how can we? Okay. So question is like to optimize reads. So I mean, how can we optimize reads? So I mean, when we
Yes,
have more reads.
yes.
Um.
Can I mold my system in such a way? Can I have some kind of a design trade-off added here, which will make my system more read friendly, and I will do writes only after. Like I need my writes to be very less as compared to the reads.
So, so how can, I mean, what if we have, I mean, instead of storing a big try, so you know, what if we have, I mean, because when we are writing in a big try, one made in one try, so what if we,
Mhm.
I mean, if we chunk it and store the chunks, and based on the ranges, if we go to that particular try and only update that try, so that we are reducing the blast radius, right? So we are just reducing it. So
So
I'm hmm,
not sure how that would impact the number of writes. So right now, what we are doing, I'll give you a hint. Right, right now, what we are doing is whenever a person clicks on chooses one suggestion, we are updating that particular frequency over here.
exactly.
Do you think that it makes sense to update the frequency every time a user clicks on a suggestion? By the way, guys, who are
Um,
looking for what
okay.
the question is we are designing a search type ahead. Yeah.
Okay, yeah. So I mean, if we do not update, so then the subsequent reach will not get the top. So I mean, so uh, so when we are reading, so you're saying instead of updating, maybe we will update later, or in I mean, in some intervals we'll update. Uh,
Mhm.
I mean, we'll just store them and then update in regular intervals, maybe
Yes. Yes.
saying.
How? Yes, that you're going in the right direction. Where can we store it? How can we store that?
So basically, so whenever user clicks on that, so we are actually updating. Instead of that, we'll store them in some message queues or something. So then in some message queues, and then we will actually have consumers that consumes maybe every hour or some regular intervals to update them.
So even that, when you're storing in a queue, that also has a problem, right? Some consumer will read that message and then come to update this particular try that we have, right? Instead of that, why not store it in a hash map? Can you use a hash map to store it somehow, and then after some frequency or after some threshold, you update the complete frequency?
Yeah, but so you're saying with message queues will have some redundancy, is it?
No, so for message queue, let's suppose I store it in a message queue. There
Mm-hmm.
is a Donald message here. There is a Donald
Yeah.
message here. There is a Donald message here. So I'll end up, whoever is consuming my message will end up updating the
Yeah.
queue the same number of times you have pushed the message. So
Hmm.
my
Yeah,
rights,
that
I'm
is
not
true.
decreasing the rights.
Yeah,
Can we use,
that is true.
make
That is
use
true.
of a hash map and decrease the frequency of writes?
Yeah. So in this case, we'll have a map that will have the that will have the frequency of each word
Yes.
in that regular interval, and then yeah, we will update in one shot. So one
Correct.
I mean, one shot we can update. Yeah.
That's true.
That is, yeah,
So
that is,
a
yeah.
criteria could be that we only update once my frequency reaches beyond 1000. And 1000 for a billion, if I consider billion search
Yeah.
queries, 1000
Yeah.
is a very, very small number, right?
Yeah.
So I
True.
can afford to have a error margin of 1000. I don't need to,
Yeah.
it need not be a very accurate margin as well,
Yeah.
right? So
True.
just keep updating the frequency in a hash map, and once you reach, let's say 1000, you update for that particular keyword. So for Donald, you'll just iterate through the tie and update the frequencies
Yeah.
plus
Exactly.
1000 to whatever it was earlier,
Yeah.
right?
Exactly.
Cool. So my one problem is solved about the right part. Now my reads are more, so I can add more parallelization. I can have I'll basically have lesser number of writes. So that inherently gives me an opportunity to cache or do all sorts of optimization.
Yeah,
But we still have this problem of storage. That entire
storage.
try, I cannot push the entire try in a single box.
Yeah, yeah, that is
So
true.
how do
So
I
yeah,
get rid of?
yeah. So like we can actually partition it in such a way that maybe I mean, I'm just iterating some possibilities, and we can actually look at the pros and cons. So one is
So
so range based partition, like all A's or all B's at once. But this will not scale well. Why? Because let's say the votes at with starting with X or W maybe less than the votes starting with other alphabet. So so again, so that will be a problem. So or we can actually take prefixes and store by prefixes. uh,
okay.
so maybe like so A to like from like AB to AD or something, so those prefixes if we store.
A to, let's say, K is something, L to M is something, and X to Z, something like this, right? Maybe
Yeah.
basically bucketing. You're basically creating the buckets.
No, I mean not like that, but still, not with length of one, but maybe three. So let's say, so there can be words like so like starting with cat. So and again, there can be many words. Maybe let's say some millions of words, and if it's so like taking the prefix and storing by those prefixes like so AB or ABC and so on.
So
Um,
I think AB is stored in one, and then AC is another one, AD is another one, and so on.
yeah.
Okay,
So
so
yeah,
let's suppose with this I'll have 26 into 26 characters. These many
machines. Yeah.
combinations I'll have, and it is not really necessary that I might have more machines, I might have lesser machines,
Yeah, that is
right?
also true.
So how
Yeah.
would you
Huh.
map this number with the number of machines that I have? Let's say I have
So,
n number of machines. So how would you map this? Uh, let's call this x number or x number of prefixes with the n machines that I have.
so we can actually do by hashing. So for a word we can have a hash function.
Mhm.
So that can actually, I mean, so when we store, so basically we'll not store all those abs in one machine, but so basically what I'm saying, so let's say we'll determine, so words starting with prefix ab or AC, AD, and so on. Some k number of prefixes will store in one machine. So I mean, like that will store in multiple machines.
Mhm.
Uh,
So the question over there is, I think what you're hinting at is that there'll be out of these, one machine will hold multiple prefixes as well.
yeah,
But how would you decide? Let's suppose I have prefix AA. On which machine this particular prefix should go? How would you
yeah.
determine that?
So basically, so these machines will be behind a load balancer. So where my load balancer will maintain this mapping. So this with that mapping, the load balancer can redirect to that particular machine.
Okay, so basically there is a load balancer which is sending it to one of the machines that is available,
Yeah,
right?
yeah,
But in the load balancer also, most of the load balancers are primarily stateless. So
stateless. Yeah,
you need to have a stateful kind of a load balancer over here. So do you
yeah.
know how to do a load balancing in stateful system? I'm just looking for one specific term. Anand Kumar R, you are right. You've used the right term. So basically, the term that I was looking at is consistent hashing, right?
Yeah, I mean, I was coming to that. I mean, as I said,
Right.
hashing there. So I
Right.
mean,
So
I'll actually eventually come, but this I got it. Got in my mind. Like, yeah. So consistent hashing we can do.
Right. So we will use consistent hashing. You've still not answered what would be the shard key. On what particular parameter? I think this is your shard key, right? AB and AA and EC, that is what your shard key. But what will you call that? Again, looking for a specific term. You've answered that in your previously.
Okay, so I mean, you're saying these prefixes. What do we call
Yes, prefixes.
them?
Prefixes is what I was looking at. So prefix becomes my shard key,
Yeah.
right? And once I have these prefixes ready, I can just push it to a consistent hashing ring,
Yeah.
and it will distribute the load evenly, and it will take care of how many number of servers are there, how many number of servers are not there. So we have
Yeah.
correctly solved the storage problem as well.
Yeah.
Any other problems that you see?
Mm. So I mean, can you go up? So I mean, the scope is only top and I mean, I
Yeah,
forgot the scope. So only top
top 5 and popularity.
and popularity. Okay. So popularity problem is solved, and top is also solved.
Right.
So, and we'll do optimization. So I mean, like as of now, I don't think so much problems here. So I mean, because the basic design is fine, like we can apply optimizations on these.
So we have introduced sharding. What if, let's suppose, this particular application server is holding AA, BA, CA, and some more data. What if this server goes down?
Yeah.
So how would you ensure that if this server also, if a server goes down, then also your system is done?
So I need to copy. I mean, I need to have these keys in another system. So that's
Correct.
one. I mean, right. So um,
How do we do that?
1 minute. So I forgot that. So
This is nothing but replication, right?
yeah. I mean, so
This is replication.
so that means we'll keep the replicas in other machines also, right?
Yes.
Or each one. I mean,
Yes.
each
So
of the prefix. So, go.
each of the prefix can be replicated to multiple servers as well,
Multiple servers. Yeah,
right?
that's what.
So
Yeah, I mean,
and that is how we can define how we are basically replicating. So I'll quickly ask you a question on consistent hashing itself, right? So let's suppose these are my server IDs 1, 2, and 3. All right.
yeah.
Now let's suppose I have one object over here.
Hmm.
Okay, this is key 1. I'll use a different color. This is key 1. Okay. Now this K1, on which server will this data will be stored for K1? Either you go in the clockwise direction or you go in
Clockwise
the
or on anti-clock? Yeah,
or anti-clockwise. So let's choose one convention. Let's go in the clockwise direction and let's store
clockwise.
it
Yeah,
in 2.
two.
So 2 is holding my data.
Yeah.
What is the next server? If let's suppose I set the replication factor equal to 2, that means 2 server needs to hold the data.
Yeah.
What would be the next choice of server? Should I push this data to 1? Should I push this data to 4? Should I push this data to 3? 2 is the ideal candidate. I have added the data, but I need one more server to hold a copy of this particular data. Which server out of the other 3 available is the best candidate for that?
Okay. Okay. So
Your options are 1, 4, and 3. 2 is already holding the data.
okay. So now two is holding. So so if we assign to 3, so the problem would be, so if we assign to 3, the problem would be, since we are going in clockwise, so if 2 is also went down, for 2, we again have to store them, store the replica of 2 in some other machine. But um, storing in the clockwise would be a problem here, because um, if 2 goes down, so we will we'll have 3 for it. um Wait, I'm not able to.
So you're going in the right direction. So where will this K1 be routed if 2 goes down?
So it will be routed to 3. So in the
Right.
clockwise, it will be routed to 3.
Correct.
So that means if we store at 3, so if 3 also goes down,
Then it's a different
so
problem.
yeah, so that's a
We'll
different
we'll
problem.
solve
But
one
yeah,
problem at a time.
yeah,
Right
yeah, I
now,
think
if 2 goes down, there should be we don't need to
3.
transfer the data from 2 to some other node. My my newer queries will be routed to 3, and 3 already has the data,
Yeah,
right? So
yeah,
my natural choice becomes 3 in this case, right?
exactly.
Right. Cool. So yeah, I think that is we've discussed enough on this. There is one more way to decrease the number of write operations.
Uh-huh.
Can anyone, you or anyone who's joined us, tell me one approach which we can use to make this property hold true? Right now, if I don't do anything, writes and reads are same. I want a system where my reads are much, much greater than my number of writes. One way that we have discussed is the hashing approach. Can you guys think of one more way to do
So
this?
as you said, hash map. So similar to that, maybe map reduce kind of thing we can use. Like, we'll have a map, and then those reduced jobs will write it down to them.
What is your mapper step here?
So whatever. Okay, so in this case, so the mappers will be. So maybe if we can store the votes and map them into, into an object, like similar to hash map. So how we map them, so we can transform them into the number of occurrences, or number of the frequency, and then pass it to reducer.
Okay. And I still don't understand how. Let's suppose this is a Donald, again using the same, abusing the Donald name. But let's suppose this is a term.
Yeah.
What would be the mapper step over here? What operation am I doing here?
Yeah, so I think here this is not possible. Why? Because we'll have multiple objects. So the map step is applied only. The transformation can only be applied on one particular object. Like, we cannot combine with other. I,
Mhm.
I'm assuming. So that's what I.
Right.
Yeah. No, I think
So
that's not a good
uh,
solution.
I'll take options that people are typing in the comments as well. So Jalkrit is saying, Jackrit, sorry, is saying that we can use a NoSQL DB as well. So any time you appear for a system design interview, you should refrain from saying terms like NoSQL. I'll use a NoSQL DB, and that will solve the problem for me. Why? See, Google search type had problem can be solved using Elasticsearch, right? It gives everything that I want out of the box. The aim for a system design interview is to judge whether if I give you a new problem, can you design it on your own? And then if you answer if your answer to a particular question is that I'll use a NoSQL DB, my question would be which DB would you use, and then I'll dissect whether you know the architecture, how that particular DB is designed or not. So unless you don't know how the architecture, how the DB is architected, do not use these terms in the interview. These are a red flag. When you know use a random technology and uh, don't know what is the architectural decisions behind that particular technology. Try to stick to the basics. If you're using caching, don't say Redis. Say I'll use a cache. Uh, and when you're saying you use a cache, it should be clear in your mind that hey, this is going to be my key. This is going to be my value, and my retrieve. This is going to be my retrieval pattern, right? That is very much essential during an interview. So keep that in mind. Yeah. Sorry. Over to you.
Yeah, I mean, so yeah, I cannot think of it.
Anyone who's done machine learning, they would,
Okay.
I think, be able to uh, get a better hang of it. It's a simple statistical tool, typically used in uh, not just machine learning. Machine learning is one area, but it's a purely statistical way of doing things.
So
So
someone said
Arpit says
Bayesian. Okay.
Bayesian. Okay, Bayesian. Not really. Uh, but what you can typically do is use sampling.
Okay.
The idea of sampling is that if it is popular, no, don't use average or anything like that. Just use sampling. If it is popular, right, there most of the chances, if you just skip 99 requests and choose the 100th request, it will be the request of the most popular one. For example, if it's a India versus New Zealand final that is going on right now, if I search for IND and missed out, just randomly choose the 100th request, it will be for India versus New Zealand. And because I have that kind of scale, I can just remove or let go of the 99% of my request and just choose one request that is coming to me. Of course, there will be some error threshold over here. It will not be accurate, but it will be a very much close to accurate guess, I would say. So sampling is one more thing that you can typically do. I'll only consider the 99th or maybe the 100th request. 99 request, I won't just care about it. And in fact, this sampling way is used in many applications, right? What I was saying is, so I'll just summarize what I just said, right? What I just said was that if something is very popular, like for example, if I type IND, IA will automatically be suggested because India has been searched by many people, right? If it is, if there is something else that is coming out of IND as a prefix, it will be searched by many other people as well. And by the law of averages or by the law of randomness, what I can surely say is that even if I remove the 99 first 99 request, whatever is the 100th request, that will the probability of getting that particular number which is popular, that is really high for a actually popular request. I'll give you a small example. I'll write as let's suppose I have four spaces, 1, 2, 3 and 4. All right, what is the probability of picking one? It's 1 by 4, 25, and so is
Yeah.
the case with every other number that is there in the array. Now let's make some more interesting. Now what I've done is I've added one more one. Now if I ask you to pick a number randomly, there are 50% chances that I'll end up choosing one. Now let's do remove one, add one more one in the four numbers. the percentage now shoots to 75% chances of getting 1, right? And this is the law of popularity. Out of the 4 numbers that I had, 1 is really popular because it is occurring 3 times. If I choose a number randomly out of this particular batch, I have 75% chances that I'll get 1. For truly popular systems, the occurrence of this 1 is over 99%, right? And that is what I was hinting at. You just sample your request, create a sample of, let's say, 100 batch. Out of that batch, pick one element randomly, and the chances are that you will end up picking up the most frequent or most frequently searched phrase. So this is a small idea about sampling that you can go back and apply in other systems as well. Yeah, I hope this leaves you with a food for thought. And yeah, cool. Anything else that you want to add, Lokesh, on the problem that we have discussed?
So on backend, yeah, I think that's it. So I mean, just one thing is that maybe on clients we need to add throttling. That so like as we are typing, so like we said debouncing. So this term called debouncing. So I mean that means, let's say if I type a, and there's an interval like like some 600 milliseconds like that. So if I stop typing, then I should send a request. If I'm not stop typing, so I should not send the request. So that debouncing maybe we'll add on clients. So
Right.
to optimize, yeah, I think that's it from my side.
I think your voice is cracking. I don't know
Oh,
if that's just me or
oh,
is it cracking.
is it
Sorry,
is it fine
it's
now?
better now.
Is it fine?
Yes,
I
yes,
mean, some
yes,
maybe.
yes, that's better.
Yeah,
All right, cool. So we've discussed a problem, a system design problem with everyone, right? And I think we are quite done with the 1 hour mark that are typically, added, given for a system design interview as well. I'll give you, before leaving, I'll give you guys a thought about uh, what are the typical challenges that people face during system design interviews, right? Pacing yourself is quite important, right? I think the pace that you showed, Lokesh, was spot on. We were able to cover quite a lot of ground in 45 minutes. We didn't touch upon many factors as well. I didn't go deep into understanding the how would you implement a try and all that, but I think that is not an objective of a uh, objective as well, right? We didn't go into things like rate limiting and things like how would you actually persist a try on DB, right? Everything
yeah,
was there in memory, so we didn't go into how would you persist a particular try, so that
yeah,
in case the server restarts, how would you handle that? We've not discussed uh, so we've not discussed the length of a particular prefix that you will add. So would you add a also as a prefix into the consistent hashing ring, or would you require a minimum length? If you're having a
yeah,
minimum, like what are the pros and cons of all those things? That is something that we've not discussed. But I think within a given the time frame, this is a decent enough discussion. There are multiple other aspects as well that we can look at. For example, personalization. Typically, if you are interviewing for a senior role, you would be asked to go into one peripheral area. I didn't get a time to dig deeper into the other peripheral features that we had missed out. The other peripheral features are primarily there to test whether your approach or the solution that you're giving is extensible or not, right? For example, if on this particular system also you want to add personalization, how would you change or tweak your
yeah.
system? Do you
Yeah.
require to change the entire logic? If that is the case, then your system is not extensible. And extensibility is a major component when it comes to testing out things, right? So I'll probably jump to questions that are there in the comments, right? If you have other prior engagements, I think I had blocked only 1 hour of your time, Lokesh. If you have any prior other engagements, feel free to drop off. I'll take the questions and then I'll wind up. Do you want to stay or
Sure,
do
sure.
you want to?
So I want to drop off because my mom is waiting for dinner. So yeah,
Sure,
I'll
sure.
drop off, guys.
All right. Thank you so
Okay,
much
guys.
for your time,
Thanks.
Lokesh. Have a nice day. Bye bye.
Yeah, thanks. Yeah, bye, guys. Thanks.
All right, guys. So I'll take up all the questions that might be there in this particular chat window. Uh, if you've still not typed your question, please do so. If you want me to interview you on, do a mock interview for you as well, please mail us your resume at youtube@scalar.com. I'll just type it down so that it's uh, visible for everyone. This is the ID that you should typically be looking at. All right, let's now go to the questions. Bhagya says fast response. Okay, these are the answers. Where are they in question? Should we handle location, current issues, and frequency, at least in count? What's the profile of the interviewee? I think Jay Kirat, we told like in the beginning we started off with the profile of the candidate. He was having 6 years of experience, an SD2 at Akamai, and prior to this he was working with Book My Show. I hope this answers your question. So Jayvant has a question. In yesterday's short URL, why we use user ID for the table if you're searching for shortcode in the whole DB and providing the actual URL won't be time consuming. How about using a key value pair? Just one that was so the schema that I wrote that was primarily for a system with a very less amount of uh, uh, which is basically designed for very less users, not for a massive scale. A KV, a minimalistic KV is the one that will work the best for a URL shortener kind of a design. So try can be partitioned based on location. That is not a good approach, I would say, Arpit. The reason being because if you break down the try on a location basis, that will be adding personalization. But what we were designing today was basically a search type head that is globally accessed, and the frequencies were also changing globally. The prefix approach that we discussed at the end is basically the correct approach. Arpit says you should not block reads. How does it matter if the value goes a little here and there? Exactly. I think what he is referring to is that when we are writing a particular system, that is when we should never, whenever we update a particular frequency of a particular record, that is when we have to basically block all the reads because the write will take a lock on the particular record, and hence reads will not happen. So we should avoid it at all cost. We have discussed two approaches to avoid that. One is hashing and the other one is sampling. So we can use either of the two approaches to uh, to basically block down the reads and write value. So I see there are many people who have told that caching is the best way to do this particular thing. However, I would like to differ from them. Caching for a search type ahead is not a very good idea, right? We are actually caching quite a lot of things in the node where we just traverse to the node and we are finding the output. we need to understand that caching by itself is not a solution to reduce the latency. For example, if I maintain a hash map in memory, that is much more faster as compared to storing the data in Redis. So whenever you are appearing for interviews and giving your answers that I'll use caching, have instead of using caching word, or instead of using this, tell them where are you going to cache it. Are you going to have a distributed cache? Are you going to cache it on the client side? Or are you going to use maybe uh, or maybe at a load balancer, or maybe at a global cache or a DB cache? Specify what kind of caching you are going to do and what is going to be the key. Here in this case, I am not sure what can be the typical key for a particular cache. How many prefixes can you typically cache also, and the frequency also. What if, let's suppose I cache, I'm taking the same example, Donald. If I cache Don and save the top 5 words, how would you update the top 5 frequency? That will become a problem, right? So I hope everyone who's actually attending the session understand that caching here is not the best way to go ahead. So Vishnu says NoSQL is a good option. I think I have spent some time describing that. Don't directly jump to a NoSQL database. Identify what are the requirements that you would need to design such kind of a system, and then discuss the trade-offs. Directly jumping to a NoSQL is a red flag, especially if you are interviewing for a higher up profile. For SD2, it will still be okay. But for SD3, it is a definite red flag. Is its memory already in memory? What will you cache? What does it mean exactly, Arpit? That is what I was hinting at. What would be the criteria for caching? I think Arpit, I've answered that. We will shard based on the prefixes. Okay. So Vineet is asking what we need to be prepared before giving an interview with you. In this particular mock interview, I had basically told Lokesh that, hey, I'll be asking you to design a Google search type ad. So the question was given to him already before he came for a mock interview. So whenever I take an mock interview with you, I'll probably give you a heads up that I'll be asking this question. The sole purpose of giving the topic beforehand is we want to have a meaningful discussion while on a mock session. In an actual interview, of course, you will not be knowing the topic, so it's important to understand the system design concepts and prepare based on that. So typically, if you want to do a mock interview with me, I can give you a topic and we can have a mock interview on that, right? Any such stream for low level design? So this system design interview is a superset of the low level design, right? It's based on two important uh, parallels. One is the low level design. For a system design interview, you need to design the schema. Schema designing comes under a part of low level design. I, as an interviewer, might ask you to write some classes and code for that particular business logic that I'm asking you to implement. If you are a more experienced candidate, I might spend more time in discussing about the systems. Right? If you have lesser experience, I might ask you to design the classes. For example, the same question: how would you go about designing chess? I would ask this question differently to a person who has maybe a college fresher, or maybe have 2 years experience, and maybe with a person of 10 years experience. For a person with with 10 years of experience, I will drill deep into how would you ensure make this particular chess game into a multiplayer game, or maybe not a multiplayer game, basically a two-player game, two-player online game.
How would he bake in artificial intelligence? How would he make sure that there is no there's no cheating component that is happening in the chess tournament? So, uh, doing uh, focusing more on the system design aspects of it for a 10 years experience. For a lesser experience, I'll probably spend time in how would you design the queen class, how would you design the pawn class, how would one extend to the other, and how would you abstract out the common functionalities. That is what I'll test probably for a with a 2 year experience candidate. I've learned from. Thank you so much. I hope I take it as a compliment. Uh, in memory, hash map is not scalable, can be used by a distributed server. So you can have a Redis cache as well in case you want to have, in case you are limited by the number of, or limited by the memory that your application servers are having. You can typically take this component out in a different system itself, right? So that would not be a problem. Is it possible to explain try implementation at DB level in your upcoming YouTube masterclass? Unfortunately, YouTube masterclass will not use any concept of try. What we can, however, do is there are people like we also take masterclasses on data structures. We can pick this topic up in one of the data structure masterclasses, not at a system design masterclass, right? And DBs, as far as I know, there are no DBs which will allow you to persist or try. Uh, right? You have to store it as an object and retrieve that as an object. For R much greater than W, keep cache on servers and have some hybrid approach for write through and write back policies to update the data back. Yes, Pratik, we can do that, but understand that tries are also stored in memory. So by having a separate cache layer, you are not actually gaining anything out of it. The amount of time you will spend on reading from a try will be closely similar to what you will to the performance that you'll get out of the cache as well, because essentially both of the systems are reading data from memory to find out the top key elements for a particular prefix. The max you have to go for is maybe 3 or 4 characters or maybe 5 characters max, and you'll get the complete string. So you are actually not going traversing a lot of data when it comes to having the reading it from the try. Redis is a event driven system and not necessarily slow need. Okay, it's he's answering to Anand. What is the question of Anand? Okay, Redis is single threaded in nature. It can slow down the entire system. So Redis, even though it is a single threaded, it can serve the kind of latencies that you can get out of Redis server is around 1 to 2 or maybe sub 5 millisecond kind of latencies. So in 1 second, you can typically serve from a single thread itself. You can serve around 500 200 seconds, and then there will be thread multiplexing can also happen. So sorry, you can have a multi-threaded application interacting with this particular thread. So that also will give your system a huge boost. So using context switching and all that, I have had instances where I can, with a single Redis server, I can serve million QPS. So Redis is blazingly fast, even though it is a single threaded application. Redis is an event driven system and not necessarily slow Node.js, but very fast. CPU intensive. So Arpit says Redis is event driven system and not necessarily slow. Is drawing parallelism from Node.js.
server. CPU intensive application do require multiple threaded system, but not which are just a network IO intensive. Agreed on this. Most of the time is spent on IO thread. So exactly. So not thread contention. I forgot the term for that. Yeah, context switching. So context switching will there'll be multiple threads which will be reading the data, and using threads will switch the context to give chances to other thread which is waiting to be get into running state. Sharding, please. I think Bhavan, what you're asking is, are you asking me to explain what sharding means? I'll be uploading one video on sharding on under the system design series, so please stay tuned. Right. So uh, if you are interested in knowing any other system design concept or topic, please feel free to comment on this video. I'll end this video now. Tomorrow, I'm going to tell you about how to answer the coding experiences, like how do I answer coding questions, DSA questions in an interview. I'll probably invite one more speaker who will tell. So uh, I'll basically invite one more speaker who is also done taken multiple coding interviews, have himself cleared multiple company coding interviews at multiple different companies, at farm companies as well. So tomorrow will primarily be focused upon how do you appear for and how do you think about a approach when you're going for these coding interviews. And day after tomorrow, I'll take one mock coding interview, similar to in a similar format that we have done today, right? So I'll see you guys tomorrow. I'll leave leave the class now. Hopefully that made sense for you. Please subscribe if you have not subscribed to our channel. Right. I'll see you guys tomorrow. Bye bye.
Hello, hi, and welcome to our weekly podcast on senior versus junior developer. We'll be doing such live events quite often now. And the topic for today is how do we debug issues in production. But before going ahead, let's take a moment to introduce ourselves. I'm Mohit Yadav, and I teach at Scalar. I've been a part of engineering teams at Hotstar and Nutanix. I was a senior developer in both the teams, and I let Pragya introduce himself as well.
Right, so I am Pragya. You might have seen me on the Scalar YouTube channel quite a lot. And I have been working I had worked at DirectEye in the past, Media.net branch of it. And since the past couple of years, I have been a senior software engineer here at Scalar. So nice to meet you, everyone. I think we can begin it now.
So let me set the premise, right, or what this session is about, and how we are going to be running this session, right? We'll the starting in the beginning of the session, we will give you the entire glimpse of how do you debug an application in the production environment, and then we'll give you a chance to ask live questions, right? So keep your questions ready. We'll give you ample amount of time at the end to ask questions. So the premise goes like this. Let's say you have built a paid application that is supposed to stream live cricket matches. Now the match starts at 8 p.m. and 5 minutes into the game, your social media teams comes up to you and says that, hey, lot of paid customers are complaining about poor experience on social media, right? They might be ranting about it on Twitter or maybe Facebook groups or maybe tons of other places to rant about, right? Now, as an engineer who is responsible for streaming this match live to millions of users worldwide, what would be your next steps? I let Pragya talk about the three pieces that we can solve for, and then we'll get started. Pragya, over to you.
Yes. So if you look at any large-scale application, right, any web service, anything like Google or Amazon or any sort of cricket streaming website that you see, you usually can divide the entire thing into three parts. Right. One is what you have is the client side, right? That is the actual user that is sitting there, and I mean they are streaming some let's say cricket matches, right? The user has their browser, they have their browser cache, they are talking to a DNS, and so on and so forth. Apart from that, you have something called the infrastructure, right? And that is basically where your code is running. So perhaps let's say the website is deployed on something like AWS. So the infrastructure in that case will be the AWS web servers, right? On which your entire code will be running. Everything, the load balancer, the app servers will be over there. And the final side, the last piece of the puzzle for us is the server side. Right? By the server side, I mean that the actual code that is running on the infrastructure. Right? So the actual code that you have written, perhaps in the language using Java, perhaps using a framework like Spring Boot, right? That is what we're talking about. That is the server side. Now, out of these three pieces, we won't really be talking about the client and infrastructure in today's session. Right? We'll be focusing particularly on the server side. That suppose that you have figured out that the problem is not on the client side and neither in the infrastructure. The problem is at an API level. Then how do you debug it in production? Right. So one thing that we can say is, let us suppose that we wish to figure out that what exactly is the problem that our users are facing. Right. So one thing that we could say is that, I mean, let's say that I was on call on the duty. Right. So what I would like to do is I would like to ask our users, right, to report their problems via Twitter messages. So I would ask the users that, hey, just send me a Twitter message, just send us a Twitter message, and basically we'll try to figure out what the problem is and proceed from there. So how does that sound?
I think that sounds good, but there are few problems with it, right? Like you're collecting the feedback that is outside the realm of your application, and that might lead to what we call as a snowball effect. Now, what is a snowball effect? If you notice at avalanche, it starts from a snow which starts rolling down, and sooner or later it becomes an avalanche if there is enough snowfall, right? The same behavior we see in the like application side as well. The more people read it, the more negative publicity your application will get. And eventually, people who are getting even a decent stream will start complaining. For example, a person who is supposed to get maybe a 720p kind of a resolution is getting a lower resolution, maybe around 320p or 480p, which is still manageable. They'll also start feeling left out, and they'll also start ranting about your application on Twitter, which is not an ideal case for any business. So can we do something to contain this fire within the realm of your application?
Fair enough. So we don't really want to publicize this issue. So Twitter messages are a no-go in that case. So what we could do is while designing our application itself, right? While designing the application, what we could have is we could have some sort of a support infrastructure, some sort of support feature inbuilt with our application. Right. Once we have that, then the users can contact us via that support feature directly, and that will also help us to identify whether the problem is on our end or whether the problem is on the client end.
Oh, that's great, man. I think you are also referring to if you have heard about Uber app support, right? They all they have is an in-app support. The benefit that we get out of it is like it contains the fire within the application. Plus, it will help us capture other insights as well, and like deeper insights like network speed, how much free memory was there in the application when this bug occurred, or is there a storage limitation on the client side due to which it is causing such issues. So we'll be able to dig deeper into the issue because a person who's just using your application might not be well have the entire context about the problem, and we can capture such problems using a client side SDK, and we can also use the same SDK to capture all any crash reports, and we can bundle these crash reports and send it to our backend servers, right? Many a times we notice that there are API changes which are not backward compatible, and these leads to errors and exceptions. The responsibility, the person who's designing this framework, he should take care of capturing such exceptions and maybe bundling them and then giving it back to backend servers. And this will, the reason I'm saying this is that it will give an insight to all the iOS and Android teams that I have, and it will tell them exactly what kind of issues their users are facing.
Fair enough. Fair enough. So perhaps using this information, I mean, I will be able to, I think, narrow down whether the problem is on the client side or whether the problem is on the server side. But I mean, currently, as we said, that we are not going to be discussing about the client side issues right now, or the infrastructure issues. We will cover them perhaps in some of the other sessions. So let us just say that it is not a client side issue right now. Okay, so I mean, I have identified that it is a server side issue. Now, what I think I will do is that I will start checking I will start monitoring the dashboards, right, to see if the HTTP responses that our website is producing are those mostly 2xx responses, right? So the 200 responses basically that the responses are succeeding. We're not getting server errors from our side, right? Similarly, if the number of 5xx errors on our system is more than a particular threshold, then what we could do is we could raise an alarm, right? That would alert the team and whoever engineer is on the all call duty. So basically, something like, so imagine if you have if you are working for a large company, then usually whenever a system is live, whenever something critical is happening, something like a cricket match is being streamed, or something like on Flipkart, there's a big billion day going on, then there will be a couple of engineers who will be on call. Their responsibility will be to take care of production issues as and when they occur. Right. So let us suppose that, I mean, what we could do is based on the error thresholds, we could raise an alert and basically get the on-call engineers to respond to it. How does that sound?
It sounds really awesome. You've raised really good points, Pragya. I'll talk about each of them one by one, right? So first point that you raised was around monitoring dashboard, right? Basically keeping an eye on the number of, or basically a percentage of requests that are failing. And we can define a threshold which can be different for each and every system, right? For example, if you're using Google search, the threshold of number of requests that can fail will be very, very low, right? The uptime or the kind of guarantees that Google provide is that their systems are able to respond to 99.999% of the times. But if we compare it with other system like payment system, for example, this number of failing requests is a frequent scenario in such kind of systems. The industry standard for payments getting succeeded is around 70%. They make it to 90%. They go to 90% by having multiple other mechanisms like retries and retries with exponential backoff to make it more reliable. But 70% is basically the industry average. And just by measuring the number of requests that are failing, that will not give me a very good insight as well. What we should typically do is we should also look at how much time how much time my 2xx request is taking. This is usually called the latency of application server. How much time does my application server take to, first of all, accept a request, do all the processing and computing that is required to answer this query, and finally respond it back to the server. The total time in this process is basically called the latency of the system, of the application server. And the reason I'm stressing on the latency part is whenever you're designing system, the latency also measure is also quite important. For example, if you're designing a Google search, type ahead, and if that suggestion that comes up, right, when you type Michael, it shows Michael Jordan and bunch of other suggestions as well, right? If you type Donald, it might suggest you Donald Trump or maybe Donald Duck. But the essence of this is basically that these suggestions are only meaningful if the latency of such systems is very low. If it takes 5 seconds to show up these results, it's quite pointless. However, if there is a banking transaction or maybe you are generating movie recommendations for users who have just signed up on Netflix for the first time, 5 seconds over there is still bearable. You can still bear 5 seconds. They'll wait for the 5 seconds. And hence, I'm saying it again, measuring this time and setting a proper threshold is not only important, but is also use case dependent, right? So this was basically the first point that you spoke about monitoring. Let me give an idea about the second point that you pointed out, which was around alerting, right? So you said that if there is a threshold reach, we'll raise an alert, and that might go to a on-call person, right? But the question is, should we like, is it fair to wake up a real person post midnight, even if he encountered just one violation of latency?
Fair enough.
The
That
answer,
would be good. Oh.
yeah. So I think that's a rhetorical question. The answer for the question is basically no. It does not make sense to do that, and it does not make sense to do raise an alert for every every sort of exception that we're getting. So we should have basically varying levels of severity, because I don't want to disturb the developers who are in a case where I'm getting huge number of 4xx, which are basically client errors. Maybe the client itself is sending me a bad request. They're calling a get API, but in the HTTP method, they're writing a post API. In that case, I don't want to alert my developer. So it also depends upon whether the alert that I'm getting is worthy of waking up a person or not. So it should have basically varying level of severity. But I want to hear your suggestions on what should be the criteria for raising an alert in case of specifically in case of latencies.
Fair enough, fair enough. So, what we can do is, since we don't want to overwhelm the person on call, what we could do is we could raise an alert only if the average latency of, let's say, 5 minutes, the past 5 minutes, if that average latency goes beyond a threshold, only then we will raise the alert. How does that sound?
So you are in the right direction, but not quite there. So I'll tell you where you are right. So the idea where you said that I'll use a certain time period for analysis, that is actually correct, right? It makes sense to observe the system behavior for a given period of time, but it does not make sense to use average as a metric, right? The reason I'll come to the reason in a bit, but before that, I would like to highlight over here that you should almost never rely on average metrics when it comes to raising alerts. Instead, what you can rely on is a metric called P99. In simple words, this P99 metric that I'm calling out is that 99% of my requests that are coming to my system will take less time than the time that is reported on against this P99 metric on your dashboard. That means that 99% requests which are reaching my system will, for example, if the time is let's say P99 is written as 10 milliseconds on your dashboard. That means that 99% of my requests will take less than 10 milliseconds. Let me give you an analogy to explain you why average matrices don't work. So the pleasant temperature for a normal human being is, let's say, 25 degrees. Now imagine if I place your head in minus 10 degrees and your feet in 60 degrees. The average temperature is still 25 degrees, right? But it's not a very pleasant experience, and most likely the person will die as well. Similarly, in software engineering, measuring the 99 percentile metrics of P99 are more important as compared to the average metrics. And this is true for any kind of a metric, not just latency, right? We look at other metrics that are quite important. So Pragya, would you like to talk about some of the metrics that are important?
So, if I'm looking at the P99 statistic, what I would like to measure is, first of all, the latency of all the APIs that we have in our system. Right. Apart from that, I would like to measure some things about the load on our servers. Right. So, I would like to measure how much disk space is remaining on our servers. Right. What is the RAM availability? How much CPU load are they facing? Right. So, basically, I mean, based on these metrics, what I will be able to do is I will be able to decide if I want to launch more servers, if I want to scale out, basically. Right, if I want to add or remove instances. And basically what we could also have is, based on these metrics, we could have some sort of a pipeline, we could have some sort of a hook that will auto scale our servers. So if the demand suddenly rushes in and we don't even have a person on call, then the software automatically will detect that, hey, the CPU load is going higher, so it will automatically launch more instances of the application. So latency of APIs, server stats, that is something that I would like to measure. Apart from that, I think at the code level, I would also like to measure the time each function is taking, right? So that would really help me narrow down at a function level, right? Basically, where the issue is happening. So it could be the case that basically the call to a particular function is taking very, very long. So if I track the times for each function call, then that will help me pinpoint the issue accurately, right? But I mean, I will have to be kind of cognizant of monitoring the latencies of functions that are involving some sort of IO call, right? So it could be the case that a function is basically making a server request, right? So I mean, I want to measure the latency of functions which are making server requests. But if the function is very simple, right? If the function is as simple as, let's say, add something, then I don't really want to measure the latency of that. So if the function is complicated enough, I would want to measure the time that function is also taking.
So with time, our approach should be that we've started measuring the function latencies. But if, let's say, this code becomes a legacy code and this has been running for like ages now, we should omit the measuring latency part, because that also has an overhead attached to it, right? Because measuring latency, the way it happens is that when a call comes to a function, the time stamp of that particular that particular timestamp is noted, and whenever the scope of that function finishes, that timestamp is noted, and then difference is calculated, and it is basically logged out to either a log, or it is flushed out to a channel where this latency is basically calculated. So you are wasting three instructions while measuring the latency. So if you have a function like add two numbers, I would rather not measure that particular latency, because I know that this is a simple enough instruction. It does not make sense to add the latency over measuring the latency overhead in this case. And I'll also like to point out some other parameters that I would like to monitor. Right, I would also want to monitor the amount of how is my heap memory looking at a given point, and how are my GC cycles happening. Right. We all know that most of the programming languages, unless you are writing code in C or C++, comes up with the concept of heap, and they also have a garbage collector, which collects the objects from the heap, right? Frees up the space for newer objects. Monitoring these will give you deeper insights on how objects are basically piled up in the heap, and it may also point out possible memory leaks that are there in your application. How you are going to find out that there are memory leaks? You can just look at the graph of heap memory, right? It will be in a form of a mountain, then a valley, then basically down, peak and down, peak and down. That downward is basically when the GC starts triggering it. So just by measuring this, just by monitoring your heap memory, also you can find deeper insights into your application, and inform your developers that, hey, this is maybe there are some memory leaks in your application. The second one is the second metric that I would want to add is basically keeping an eye on the number of active threads or connection that my application is making. This will give insights if we can parallelize tasks in the applications or not. And the last point that I want to add is around file descriptors. I don't know if you know about file descriptors or not, but file descriptors are basically opened whenever you open up a file on the OS. Right? You might have seen. So just go back and do this experiment in any programming language. Open a file, write a for loop, open up and in that for loop, it should be an infinite for loop. Don't do anything, just do try opening files in that particular for loop. Eventually, there is a limit on the number of files that can be opened in an OS operating system, and that limit will be hit and you'll get an error. So there are systems which are basically based on the file descriptors as well, right? For example, Kafka. If the number of file descriptors are quickly increasing, and they are on its way to eat up all the file descriptors that can be basically the OS limit, then it does make sense to raise an alarm to the platform team and alert them that, hey, this is the kind of issue that we are fixing. You might want to do something about this particular issue, right? And using these metrics, we can decide around allocating or removing resources that Pragya has already spoken about. We can scale in or scale out depending upon the load. Uh, all of this will basically help me in automated addition of resource or automated removal of resource behind the load balancer. Right? If you have worked on AWS, you will get to know that these are the kind of this auto scaling thing that me and Pragya are basically saying it again and again will come up is basically a service that is offered by AWS, and these are the standard parameters on based on which you can increase the number of resources.
Cool. That makes a lot of sense. But coming back to the topic, maybe the issue is still not solved. So using these metrics and basically using all these charts and monitoring things, maybe I've figured out what the exact problematic API is, and maybe I have even narrowed it down to a particular function. Right? But I might still not know what the exact issue is. So I am thinking that now is the right time to start looking at the logs, right, and see if we can find something over there. So what I would want to do is I would try to basically look at what servers we have. I would assess it into one of those servers, right? So I'll just open my terminal. I'll open something like iTerm. I'll assess it into my server. I'll navigate to wherever the logs is located, and I'll just tail that log, right? I'll try to read the last few lines of that log to see if I can find what the exact issue is. So I mean, what does that sound like?
So if we have multiple, let's say I just have 3-4 servers, so I can use the iTerm window itself to basically broadcast input to multiple servers, and I'll primarily, if I want to just check whether there are exceptions or not, I can also grep for that particular exception keyword into that into the logs, right? But this approach also will not scale, right? Typically, in any company of a decent size or decent volume, those companies have like hundreds and thousands of servers. It is impossible to SSH into each server. So what you can do is you can ask each server to basically direct the logs into a centralized location. Now this centralized location is basically responsible for storing logs from all the services that are there in the ecosystem. So, for example, in AWS, there might be, for example, in Amazon, there might be a service corresponding to order management. There will be a service which will be responsible for inventory management, for example. We'll collate logs from all these services, different services, and put it into one place. The benefit that we get out of it is that once we have all the logs from all the services in one place, we can throw all these logs into a system like Elasticsearch, and we can write queries and the same grep command that you're doing on while SSHing into a particular instance. We can do it at a centralized location. I don't have to, go into thousands of VMs and find out whether there was an exception or not. But there is still one more problem with this, right? And this problem is not not at a log. How do I go into the log and find it out? This is more of a logical problem, right? To give you a glimpse of what this problem is, just imagine how a particular API is written, right? Whenever an API is written, or to write a API, typical typical structuring of your code is like that. You start from a controller. So your controller is where your APIs are basically defined. From the controller, the request goes to a handler. From the handler, the request will go to a service. From the service, the request will go to a database layer, fetch something, and then return back. Or it might be a case that a service calls another dependent service, which might be a different different system altogether, right? And exception can occur in any of the layers that I've just described. Each layer might have different functions, right? The crux of the problem that I'm getting to is that exception can occur in any of the functions, right? And the entire context of the request lies in the controller. How do I pass this context, the complete context which was there in the controller, to the function in which the exception occurred? One way to do that is that I pass the exact request params that are passed during my API call to every function, right? I can create an object of everything that is there in my application, like everything that was passed to my API controller, pass this particular object to each function that is responsible for processing this particular request. But this is far from ideal, right? What if each layer is developed by a different set of teams or different developers? How do I avoid manual errors? Let's say I forget to pass this outside of my service, and the exception was occurring in the database layer. Now, if I forget passing this particular, request to any of the functions, the subsequent function calls will not have context about the exact request that was there. So, can we do better than this? A slightly better way to do this is generate a unique ID as soon as I get a request and pass this unique ID in all the functions. This way, I'm not passing the entire big request object. I'm just passing a string. Maybe I can generate a UUID out of it, and I'm just passing a UUID. However, even this approach is prone to manual error, like manual errors, right? So, a common practice to avoid this kind of a thing is, uh, and this is where this basically works because we want everybody to each function basically to follow this kind of a practice that while logging, I'm logging this particular unique ID that I generated in the beginning of the API call. So there is a chance to externalize this responsibility to a framework. In Java world, it is called AOP, aspect-oriented programming. I don't know if you guys have heard about it. This is called aspect-oriented programming, where this aspect will be attached to each and every function, and the responsibility of this aspect is to pass on the unique ID that was first generated. Right? There are many logging frameworks that has this kind of a functionality inbuilt. Right? Uh, so using this approach, I've solved for the problem of issues arising within that particular application server. But in reality, to process a particular request, we might end up calling multiple services. For example, to render the homepage of Amazon, we might need to render promoted links, like we might want to promote item like OnePlus, maybe a new iPhone that is getting launched. And we also need to show recommended content based on the user's previous order history. So if a service A calls service B, we need a system that will help me trace the request, not just in service A, but also help me in identifying the same request when it goes to system B as well. This kind of a mechanism, which will help me trace requests from one system to another, is basically achieved by something called as a distributed log tracing frameworks. Right? There are frameworks like Sleuth available, which will give you the exact functionality that I've just spoken about. And the way this works is, you might be wondering how would the request, how would I pass the ID which is generated in service A to service B? The way it is done is that I attach this unique ID into the HTTP header. So whenever service A calls service B, it will attach this unique ID in the HTTP headers. Service B will read this HTTP header around the logs. This is called spans. Will read this particular ID and print it the same way service A was printing it. Right? So this is all you need to do to trace an exception that originated from service A and ended in service B. Right? So we've touched upon multiple, just in a very, very short time. I'll open up for questions now. If you have any questions around this, please feel free to ask them now.
Right, so over to you guys, the audience. If you have any questions, put that, and we'll be taking those questions. Okay. Cool. So I did see a question pop up on the screen just now, but the question is gone. Yeah. So
is there? Uh, is these stats depend upon platform we use like Node.js or Spring Boot, or which one is better in production. So I've massively worked on Spring Boot. Spring Boot have an open source library of cloud utilities, right? We have Sleuth, which works particularly for Java based Spring Boot applications. But there are open source equivalents as well, right? Which are basically polyglot in nature. So in those cases, it does not matter whether your service A is written in Java or service B is written in Python. Like, it does not matter which language you're using, it will work. People have come up with standards that, hey, for sending this log to the next application, this should be the header name. And all the applications and all the client libraries are built using those standard semantics.
Also, Mohit, I think Rahul's question is a little bit came a little bit earlier. I think he's asking about the statistics, what the server statistics that we are measuring. So you told me that we have to measure things like the number of CPU threads that are running, the file descriptors, and I myself wanted to measure the function latencies and API latencies and stuff. So I think Rahul is asking about that. So could you touch upon that, perhaps?
So yes, so I think it makes sense for Node.js application also. At the end of the day, all the application need system resources, right? We need all the application servers will need matrices to rely on. Like latency is polyglot, right? By the way, polyglot is that your application or your entire ecosystem of applications that you've built is written in multiple using multiple languages. So these latencies and matrices that we spoke about are basically not language dependent, and all the high level languages that are there right now are basically taking care of the memory by themselves. So in one way or the other, they will need to clear out the garbage that is basically collecting. Memory management is done by those languages. So yes, it helps in measuring those. The short answer is yes, it helps to measure this irrespective of what language you're coming from.
Perfect.
I hope I answered your question, Rahul. We'll go to the next question.
So which are the tools used for monitoring thread dumps, heap spaces, and other metrics? So yes, Mohit, could you say something about this?
I'll take this up. So there are multiple tools, both open source like there are. If you are looking for open source framework, there's JProfiler, which you can attach in your one of the servers that is running, which will give you a very detailed view of what all things are happening inside your heap memory. It will just give you a throw up a heap dump. For example, if the heap size is 4 GB, it will throw up a 4 GB heap dump, and you can use some JProfiler to analyze what exactly which object is taking the most amount of memory in your to offer other matrices that we spoke about, like latency and all that. That open source version is you can use Grafana or Graphite to basically push out the matrices, and you can use Graphite for plotting out the graphs. The paid version, however, is basically you can use New Relic. There are Datadog. There's a company called Datadog. Those are basically simpler to set up as long as you're like willing to pay them a hefty amount. You can use them. Otherwise, you can go for the open source variants.
Cool. So I think we can move on to the next question. Yes.
Can you provide an example of file descriptors? Okay. Can you provide an example of a file descriptor? So I told you, right? In Kafka, so the way Kafka stores its messages is that I have to give some context about Kafka here. That's what I was thinking. So the way Kafka stores its messages is it opens up a file. That file corresponds to a partition, and partition corresponds to a topic. So at the end of the day, all the messages that are coming to Kafka are basically stored in file. And whenever you have to write a particular message to a file, that will be to write a message to a file, you will have to first open a file and then write a message, and then only you will be able to close it. Now let's suppose the number of partitions are huge. You've created, like I'll go into, I'll digress from the current topic if I go into detail. But let's suppose to achieve scalability, what you did was you created multiple partitions of that particular topic. That will end up creating multiple files on the operating systems. And if you start writing to all the topics at one, or all the partitions at a single time, you will face problems like of file descriptors exhausting out. I hope that answers your questions, G. How to debug an issue where a set of users are experiencing slowness in global app like Amazon and Netflix? Ratnesh, that is a excellent question, and that comes under the purview of infrastructure piece that we are not covering today. A short answer for that is it might be due to DNS which is getting misconfigured. It is very much possible that, let's say, I am sitting in India, and in the DNS resolution step, what happened was that I was returned an IP address of, let's say, US, right? So that will inherently add a latency of 200 milliseconds because India and US are geographically quite distant from each other. So that's a short answer. We'll do a separate session on the similar lines where we'll dig deeper into the infrastructure issues as well, and client side issues also, right? For example, if I talk about just one line of about client side, it is very much possible that the stream that I'm sending to the my client is not compressed. If that is the case, then it will experience a lot of slowness. So those are some kind of client issues. So we'll do a session on both of these in future. Don't worry. Any other questions, guys?
Cool. So I see this one nice question from Jeet. Jeet is asking the following. Can you take this up, perhaps?
Yes. Can you give some tips on how the on-call support engineer should start debugging? Like, should he start from infra exit or heap first? Okay, that's a great question. Let me sum. This will basically give us a chance to summarize our discussion as well, right? So the first thing is identify whether it is a server-side issue, infra-side issue, or is it a backend issue. How you are going to identify that? If the problem is coming to you, chances are it will be a backend issue. That's why we did this problem, right? The way to negate a infra side issue is monitor on your load balancer. So if you're deployed your application on AWS, AWS load balancer will give you a metric about how many 4xx and 5xx and 2xx are there. If the number of 5xx are alarmingly high, chances are it's a backend issue, right? AWS also gives you a way to monitor how much time each request is taking. So if the latency of a system is going for a toss, that means it's again a backend issue. Using this, you just have identified that, hey, this is the backend issue, right? Then you drill down which API is causing this kind of a problem. Again, the friend over here is your monitoring dashboard. Have a like monitoring setup. The way you set up monitoring is either you can go for open source versions where you measure the latency of every API, or you go for a paid version which will do it out of the box for you, right? After you have identified which API is causing the issue, you drill down into that API by using the logs that you are getting logs that you're connecting, right? So using this, you'll basically narrow down the problem to exact issue that you have, exact issue that is basically coming up.
Cool. So I think this is another interesting question that we have.
How do you debug issues when a cluster is running in different regions? So simple answer is that monitoring dashboard will basically define where exactly your application servers are running and which application servers are performing different tasks. So typically how you set up monitoring in those cases is you have different dashboards for different regions. So have a collated view. So I did this in Hotstar as well, which was live in US and India at that time. So we had a separate counter and separate latency metrics for US and a separate latency metrics for I'm just using latency, but there were a bunch of other matrices as well. We spoke about them in the past, and a bunch of matrices in India data center. The reason we set up a different monitoring on both of them is because the data center, inherent data center, which is serving Indian users and US users, are different, and that's the reason we like both of them will have issues, will report issues separately. Right? It's just that Hotstar.com for US users will resolve to US data center, and Hotstar.com for Indian users will be resolved to India data center.
Perfect, perfect. This seems like a really interesting question. Chahat has a question about low load services.
I proved one error out of four. Made a certain. Cool. I will give you a very good analogy for this, right? I'll give you a good example where such kind of systems will occur, right? So, assume you're building a Netflix ingestion pipeline. Okay. Ingestion. What a ingestion pipeline means? That let's suppose Netflix comes up with a new show and it wants to air a new episode in that particular series. So that is actually a very time consuming task as well, right? Typically it will take uh, hours for a person to upload it and take it live to the end audience. The reason is that it will go to multiple quality checks, both manual and automated. There'll be checks in the frame as well. So the kind of TPS on these kind of systems is very low, and even if one request fails in such kind of scenario, even if one request fails, that means there is a huge amount of customer base which will get impacted. So I should definitely raise an alarm in case there is even a one failure. To avoid waking my on-call engineer on the night, what I can do is, if this is not a fire, depending upon the feature, right? Let's suppose the video that I'm trying to ingest in the Netflix system has to go live next week. I still have time. I will raise an alarm. I will send an alert, but the actual call to the person will go in the morning during the office hours. So those things are. I'll basically change my alerting mechanism, not my monitoring system. Monitoring system still remains intact.
Cool, cool, cool. That makes sense. Ankit is asking, can you talk about some tools that you can use to automate the alerts?
Right, right. So one of the just explore elastic stack, okay, for all these kind of questions, for monitoring, for logging, for distributed tracing, for alerting. Use the elk stack. That stands for Elasticsearch, Logstash, Kibana, the newer version of Kibana especially has a capability to send alerts as well. For doing an on-call kind of a duty, if you want to manage who is, let's say there are 6 developers in the team, there's one developer from the team takes care of the entire infrastructure for 1 week, and then you rotate among the people who are there. So for doing this specifically, there is a tool called PagerDuty. It's a paid tool that you can use. With PagerDuty, you would be able to call the person, send an SMS, send a pager alert, and do a bunch of other tasks as well.
Interesting, interesting. Cool. Jeet has a question about that his company is using P70 matrix instead of P99 matrix.
Wow.
So could you talk something about that?
That's a very so I would say that P70 will not give you good insights. I think maybe the reason why your company is using a P70 kind of a metric is the SLAs are basically defined that way. So typically, when you have enterprise contracts, right, you have to define how much would be your P99, P70, or P50. There's a P50 as well. So it starts from P50, P70. 70 is the first time that I'm hearing it. P50 is there, P75 is there, 95 is there, 99 is there, and 99.9 is there. And usually when you have a service level agreement for between enterprises, you have to specify that what would be the threshold or the max limit for these metrics, right? So maybe the project that you're working on, the contract was that 70% of my request will, I'll basically please 70% of the customers. But as an engineer, your goal should be to look at P99, or maybe if you are a rockstar engineer, then look at P99.99. You can add as many nines as you want.
Cool, cool. Ratnesh has a really interesting question. Ratnesh is saying that debugging is good, but we should try to avoid the problem in the first place. So, when we are writing the code, what can we do so that debugging becomes a lesser hassle and we
Right.
can do debugging really fast?
Yes. So if you remember the first thing that I told you, right? If you're an application developer, for example, Android app developer, the exceptions are occurring on the mobile devices and not at the server. So whatever exceptions are occurring on the mobile devices, you won't get a chance to know about them. That's the reason it becomes essential that as soon as an exception is occurred, you log it in the system memory, Android device, right? And from that Android storage, once a person is connected to internet again, send that error report to the backend people, so that they can go and debug that particular application. Uh, for others, right? For backend systems, having a so typically how people do it is, as soon as they get an exception, they keep a monitor on their logs. As soon as they get an exception, or maybe you would have written try catch block if you're a Java developer, right? In the catch block, just put that exception into a queue, right? People call it a dead letter queue. Put that exception into a queue, and there is a special person who can look into what are the exceptions, what are the most common exceptions that are occurring, and you can look into that. Paid solutions for logging exceptions and doing all these exception analytics is Sentry and Crashlytics. I think they have they also have an open source variant or a community edition. I'm not sure about that. Just go and have a look at whether they are providing a community edition. But paid solutions are already there.
Cool, that is interesting. I am not seeing any more questions in the chat as of now. So, guys, if you have any more questions, please keep them coming.
Yeah.
Okay. So we'll just
You
wait
can-
for a couple of minutes.
You can, or what you can do is, you can even after the session is ended, put your question in the comment, right? That will help us. We'll keep we keep on looking at the comments, and we'll reply back if you have any questions. Also, I would request everyone to please comment about specific areas that you liked about the video. That gives us encouragement and motivation about doing such sessions in the future as well. And please like, comment, and share, and subscribe to our channel. Grow and spread this word. This is a free initiative that we have recently started, where we will help in helping each and every engineer um, grow and upskill themselves. So please do like, comment, and share, and subscribe to our channel. Yeah. How to Sunil has a question. I'll take this as a last question. How to handle garbage collection in time of multiple ticks or threads? So garbage collections are specifically for Java. You have special collectors that you can have. You can configure the kind of collector that is running. There is G1 GC, there is serial collector, there is parallel GC, there is concurrent mark and sweep. So multiple algorithms are there for garbage collection. For others as well, I think Pragya can talk about if you want to talk about some how does GC works in Python, and if you can configure a garbage collection algorithm.
Right. So I'm not sure. Python does allow you to hook into the GC. So I think the library for there's an inbuilt library in Python which is literally called GC, right? And you can basically hook into it to figure out when an object is being garbage collected. I think you can plug and play different algorithms in there as well, but I'm not exactly sure. You will have to check that library. But if you look at any sort of programming language that is used for web services and that has some sort of a garbage collector, you will be able to that programming language will definitely support a library to hook into garbage collector and basically try to configure. You can try to configure basically when the garbage collection happens or what algorithm the garbage collection use. You can basically tweak those things. Does that make sense? I'm not sure if that answers your question. So your question is more specifically how to handle garbage collection in time of multiple pings or threads. Is that your question? Multiple pings or threads?
I think it's multiple things. Okay. So you cannot control garbage collection. You cannot say to the garbage collection that start collecting the garbage now. You can, however, hint it, and it depends upon the algorithm that you're using. It might honor your request or it might reject your request as well. So there's nothing special that you can do in terms of that I want to collect the garbage now. That is not possible. Even in
So
Java.
one thing that you have to take care of from a design perspective is that, I mean, you have to look at how your application is managing the objects. In case your objects are forming a very large graph, right? If they're forming a large cyclic graph of objects that are dependent on just one variable, right? So imagine that there is one variable that is talking to an object that is basically referring to an object, and that object in turn is referring to an entire tree or an entire graph of objects. Now, if this variable goes out of scope, what will happen is the garbage collector will kick in very late to clear up this entire graph. Right? So you should try to make your design in such a manner that this thing does not happen. Does that make sense? So that is something that you can do. Now, of course, for garbage collection, there's a lot of other things that you can do. So perhaps what we can do is we can have a separate session on that sometime on the
I think
skill channel.
there are multiple people who are requesting for a session on garbage collection. So we'll probably plan a session alongside after we are done with infrastructure and client. We'll probably plan a session around garbage collection as well. Cool. Keep the interesting suggestions. When if you have any suggestions around what topic we need to do, please comment that topic name. Just the topic name in the comment. We'll make sure that we do a session on that one. All right. I hope the session was informative and interesting for you, and I'll hope to see everyone in the next session.
Perfect.
you
So
so
one more thing that I would like to mention, Mohit. So apart from this particular session, in this junior developer versus senior developer theme that we are having, what other future videos are we expecting to see? Can you comment something about upon that?
So we'll have a video. So next we are planning to have is a session on. So this was basically a tech-oriented session, right? And technical skills is not the only thing that is required to climb up the ladder. So we are planning to have a session on soft skills. You won't believe the differentiating criteria between my interview at Facebook was basically on the soft skills aspect, right? So they say that the technical interviews are basically a filter criteria, and whether you'll be offered a position as SD3 or SD2 depends upon how you portray yourself in the team and how do you manage team, right? Manage your team. So we are planning to have a session on soft skills specifically, probably next time. And we're also again we missed out on the client and infrastructure side, so we'll also have a session on that. We'll have sessions on how do you develop a app, like roadmap series kind of a session. How do you develop an app from start to the end? So those are the things that are there in the pipeline. Hope to
Perfect. That sounds interesting. So, as we said, guys, keep the questions coming. Basically, we will be ending the session, but we'll be monitoring the comments that you are posting, and basically, if you have an interesting question, we'll be replying to that. All right. So that is it for this session. Hope to see you guys in the next session. All right. There are many more to do. So see you then. All right. Bye bye.
Bye bye.